Dalam bola gitu.
Selamat pagi, Bapak Rektor.
Kita nggak host atau co-host mana bisa meng-mute-kan host.
Selamat pagi, Pak Direktur.
Selamat pagi, Bapak Ibu pimpinan, Bu Isda.
Pagi, Bapak Ibu, Bu Maniar.
Ya.
Halo? Oh, di mute Mama tapi kedengaran. Oh, iya Kak.
Apa?
Mungkin tadi sempat memang belum di mute Mama katanya. Iya.
Ini nanti rekan aja spinya sambil itu nanti abang kan biar muncul di apa spinya spi cakrapung itu. Oh di layarin aku bikin semua. Panjang kali soalnya memang. Tapi kalau yang si Barapa itu abang singkat tapi tampilkan aja juga bisa abang share gitu ya. Mana dia? Profil di PowerPoint profil ini dia ya.
Well, ladies and gentlemen, especially all the participants of this conference, we would like you to rename your username rxx_ full name, for example, R01_ Damanik. Ya, bagi peserta atau hadirin yang belum merubah username, silakan merubah username menjadi rxx_ kemudian nama lengkap seperti contoh R01_ Damanik.
Sudah ada. Kalau itu ya nanti saya buat nama kan. Tapi nanti ditampilkan juga.
Untuk contoh dapat dilihat di running text yang telah disediakan. Ladies and gentlemen, we cordially invite you to be ready on your screen because in a few minutes the ceremony will proceed in no time. Hadirin sekalian, dengan hormat kami mengundang Anda untuk bersiap-siap karena dalam beberapa menit lagi acara akan dilaksanakan. Yeah, we would like you to unmute the microphone if you are not going to have a response. Kami juga memohon kepada seluruh partisipan untuk memposisikan mikrofon dalam keadaan unmute.
Pagi, Pak Pimpinan, Pak Direktur. Waalaikumsalam.
Selamat pagi, Pak Rektor.
Waalaikumsalam, Pak Rektor.
Pagi.
Assalamualaikum, Pak Rektor.
Salam, Bu Ketua DMP.
Assalamualaikum, Pak Rektor. Selamat pagi.
Waalaikumsalam.
Assalamualaikum Pak Rektor. Assalamualaikum.
Salam, Pak Prof.
Assalamualaikum Pak Rektor, selamat pagi.
Satu pagi.
Assalamualaikum semua.
Assalamualaikum warahmatullahi wabarakatuh. Assalamualaikum Pak WR1.
Waalaikumsalam, Bu Isda, cantik kali pagi.
Assalamualaikum Prof. Apa nih? Dari Malaysia.
Waalaikumsalam, ya saya.
Bu Anita.
Ya. Dengar ya suara saya?
Dengar, jelas.
Dengar Prof.
Sehat semua?
Sehat.
Alhamdulillah sehat semua.
Semua duduk berasingannya di rumah atau di pejabat ya? Tak ada di
pejabat.
Ada yang di rumah dan di pejabat.
Sama. Work from home ya.
Pak Hendro. Pagi Pak Hendro.
Ya, selamat pagi.
Pagi-pagi Pak.
Apa kabar Pak? Sehat Pak. Ya.
Alhamdulillah.
Ya.
Assalamualaikum Pak Hendro. Jumpa lagi kita pagi.
Assalamualaikum, waalaikumsalam warahmatullah.
Sehat-sehat Pak Hendro ya.
Ya, alhamdulillah Pak. Alhamdulillah. Ini Pak Tukiran sudah ada ya?
Iya.
Oh itu Pak Tukiran tuh. Selamat pagi Pak Tukiran.
Selamat pagi Pak Endo, selamat pagi semua.
Yuk, ya.
Hello, good morning, Prof. Chakrapong.
Good morning, Marcel. Good morning, everyone.
Oh, you very, look like very young, very young.
Yeah. Oh, thank you.
Okay, Prof. Chakrapong, how are you today? Good?
Yeah, very good. Actually, sorry, I don't know. I have to attend the opening ceremony. Sorry. But that's fine.
Yeah.
This is today is a little bit tight schedule for me, but everything that's fine.
Yeah, I know.
So maybe after I talk, I will leave because I have some trip in domestic. Sorry for today, but very welcome for talking in the morning.
Okay, good. Thank you.
Hopefully, I can visit the Medan next year.
Yeah, next year.
Hello, Professor Chakrapong. How are you?
Hello. Nice to meet you.
Yeah, I'm Rahmat Hussain.
Yeah, Professor Rahmat. Nice to meet you.
Yeah, Rahmat. Nice to meet you too. We have the same time actually, in Bangkok, in Medan, in Indonesia.
Yeah. I think same time. Now it's 8:40 in Thailand.
Yeah, that's right. Exactly the same. 8:40. Yeah.
Baik, Pak. Selamat pagi, Pak Rektor, Pak Direktur.
Bapak, Pak Asril. Kalau sudah bisa dimulai.
Ya, para keynote speaker kita sudah hadir semua, Pak Rektor.
Silakan.
Ya, terima kasih, Pak.
Sekali lagi kami mengingatkan kepada seluruh partisipan untuk meng-unmute mikrofon dan juga mengaktifkan kamera selama acara berlangsung. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. The Excellency Rektor of Universitas Negeri Medan, Bapak Dr. Samsul Gultom SKM MKes, The Excellency Chairman of Unimed Senat, Professor Dr. Sawal Gultom MPD, the Honorable All Rector Vices of Universitas Negeri Medan, the Honorable Director of Postgraduate Program of Universitas Negeri Medan, Professor Dr. Bornok Sinaga MPD, and all the vices, the Honorable, the Deans, and all the Chairmen of the institution in Universitas Negeri Medan, the Honorable Distinguished Keynote Speakers, Professor Chakrapong Kakao, PhD from Nakhon Pathom Rajabat University, Siri Prapa Kajang, PhD from Chiang Mai University, Professor Dr. Hajah Aniwati Muhammad Lokman from Faculty of Computer and Mathematical Sciences, University Technology, Mara, Dr. Insinyur Hendro Cahyono DEA from National Nuclear Energy Agency of Indonesia, the Honorable Chairperson of today's online international conference committee, Bapak Dr. Juniastel Raja Guguk MSE, and last but not least, the honorable guests and audiences of today's international conference. Welcome to the second International Conference on Science and Technology Application, ICOSTA 2020 at Postgraduate School Universitas Negeri Medan on November 3rd, 2020 with the theme Disruptive and Science and Technology in Industrial Revolution 4.0 Era. For the first agenda of this conference, we would like you to sing Indonesian national anthem, Indonesia Raya. Ladies and gentlemen, may we invite everyone to invoke the Almighty for the success of today's international conference. Ladies and gentlemen, we invite Bapak Dr. Wisman Hadi M. Hum to lead the prayer. Kami persilakan kepada Bapak Dr. Wisman Hadi M. Hum untuk memimpin pembacaan doa.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Sebelum kita memulai acara konferensi internasional ICOSTA kedua ini, marilah kita berserah dan menyerahkan diri kepada Allah Subhanahu wa taala sembari memohon ridho dan ampunannya. Bapak Ibu hadirin yang saya hormati, izinkanlah saya memimpin doa secara Islami dan mohon berkenan menyesuaikan doa berdasarkan keyakinan masing-masing. A'udzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Hamdan yuafi ni'mahu. Ya Rabbana walakal hamdu walakas syukru. Allahumma salli ala Muhammadin fil awali wal akhirin. Allahumma ya Allah ya Tuhan kami menyampaikan puji dan syukur kepadamu atas segala rahmat dan karunia yang telah Engkau curahkan kepada kami, kepada para pemimpin kami, kepada masyarakat dan negara kami. Allahumma ya Allah ya Rabbana ya Karim. Jadikanlah acara konferensi internasional ICOSTA 2 ini sebagai majelis ilmu yang bermanfaat dan hasilnya berguna bagi masyarakat dan negara. Ya Allah, ya Rabbana, acara ICOSTA kedua ini kami lakukan secara virtual di tengah-tengah pandemi COVID-19 yang masih mewabah. Tidak lain hanya untuk memperoleh ridho-Mu. Untuk itu ya Allah, berilah petunjuk dan bimbingan kepada kami, agar kami dapat melaksanakan acara ini dengan baik, guna memberikan manfaat kepada bangsa dan negara, serta kemaslahatan umat manusia. Allahumma ya Allah, ya Rabbana, ya Karim, ya Tawwab. Jadikanlah kami yang hadir di ruang virtual ini, para pemimpin kami yang tercinta, para pembicara yang sangat cendekia, panitia yang bijaksana, peserta yang antusias, dan hadirin yang terlibat memiliki sifat amanah, karena kami yakin dengan amanah kami mendatangkan ridho-Mu ya Allah. Ya Allah, hanya kepadamu kami melakukan pengabdian dan hanya kepadamu kami memohon pertolongan. Anugerahkanlah kepada kami tekad, kekuatan, keikhlasan, lindungan, dan bimbingan untuk selalu berkarya demi pengabdian padamu semata, ya Allah. Ya Allah, Tuhan kami, Engkaulah Sang Maha Pengampun. Ampunilah dosa dan kesalahan kami, dosa pemimpin kami, serta dosa dan kesalahan kedua orang tua kami. Perkenankanlah doa dan pinta kami. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azabannar. Subhana rabbika rabbil izzati amma yasifun. Wassalamun alal mursalin. Walhamdulillahi rabbil alamin. Assalamualaikum warahmatullahi wabarakatuh.
Ladies and gentlemen, next we would like to invite to the stage to deliver his welcoming speech the chairperson of today's conference committee, Bapak Dr. Juniastel Raja Guguk MSI. Please take your time. Kami undang Ketua Panitia Seminar, Bapak Juniastel Raja Guguk MSI untuk menyampaikan kata sambutan dan laporan Ketua Panitia.
His Excellency, Rector of Universitas Negeri Medan, Dr. Syamsul Gultom, SKM MKes, His Excellency, Chairman of the Unimed Senate, Professor Dr. Syawal Gultom, MPD, the Honorable Professor Chakrapong Kakao, PhD, from Nakhon Pathom Rajabat University, Thailand, Dr. Hendro Cahyono, MSc, Professor Research on National Nuclear Energy Agency of Indonesia, Professor Dr. Anitawati Muhammad Lukman from University Technology Mara, Selangor, Malaysia, Assistant Professor Dr. Sri Parapa Kaichang from Faculty of Associated Medical Science, Chiang Mai University, Vice Rectors of Universitas Negeri Medan, Director of Postgraduate of Universitas Negeri Medan, Professor Dr. Bornok Sinaga, MPD, Deans of Faculties of Education, Language and Arts, Social Sciences, Natural Sciences and Mathematics, Engineering, Sports Sciences and Economic of UNIMED, Vice Director of Postgraduate School of UNIMED. Good morning and best wishes. Ladies and gentlemen, the second International Conference on Science and Technology Application presents 4 distinguished invited speakers from Thailand, Indonesia, Malaysia, and Chiang Mai University. In addition, presenters come from various government and private universities, institutions, academy, and schools. Some of them are researchers from National Atomic Energy Agency or Batan, from Malaysia, Iraq, UNSIA, UNP, University of Indonesia Jakarta, IPB Bogor, Institut Teknologi of Bandung, Universitas Negeri Malang, Brawijaya University, UPI, BMKG, Abdurrab University, ITS Surabaya, USU Medan, UGM Yogyakarta, Ministry of Communication and Informatics Republic of Indonesia, Research Center of Tekmira, Ministry of SDM Indonesia, of course, also from UNIMED. Those who have sat and will sit in the oral defense examination. The additional information, there are 47 institutions, including from national and international, were interested and get involved in this conference. Besides that, there are 160 papers received by committee, some of which are presented orally in parallel session and others are presented through posters. The articles will be reviewed and published by Journal of Physics conference series that indexed by Scopus. Grateful thanks to Director and Vice Director and especially for Rector of UNIMED, who always coordinate the organizing committee and the team who keeps cooperating in running this conference. Finally, I would like to invite His Excellency, Rector of Universitas Negeri Medan, to deliver of an opening speech, advice, request to opening this event officially. Thank you very much. Good morning and best regards. Thank you.
Ladies and gentlemen, without further ado, now please help me welcome Rektor of Universitas Negeri Medan, Bapak Dr. Samsul Gultom SKM MKes, to deliver his welcoming speech and open this conference officially. Kami mengundang dengan segala hormat Rektor Universitas Negeri Medan, Bapak Dr. Samsul Gultom SKM MKes, untuk menyampaikan kata sambutan sekaligus membuka acara konferensi ini secara resmi.
Baik, the Honorable Professor Dr. Jak Rapong Khaekau, Nakhon Pathom Rajabat University from Thailand. The Honorable Associate Professor Siriprapa Khaejaing PhD, Faculty of Associated Medical Science, Chiang Mai University from Thailand. The Honorable Professor T.S. Dr. Hajjah Anitawati Muhammad Lukman, Faculty of Computer and Mathematical Science, University Teknologi Mara from Malaysia. The Honorable Dr. Insinyur Hendro Cahyono, DEA, National Nuclear Energy Agency of Indonesia. The Honorable, the Head Senator Universitas Negeri Medan, Profesor Dr. Saul Gultom MPD, all Vice Rector, Dean, and Director of Postgraduate Universitas Negeri Medan, Profesor Dr. Bornok Sinaga MPD, the Head of the Institute Research and Community Service UNIMED, the Honorable, the Head of the Institute for Educational Quality Development and Assurance, Universitas Negeri Medan, and all lecturer, research, student, and all participants. Welcome to the second International Conference on Science and Technology Application hosted by Postgraduate School of Universitas Negeri Medan. Let me deliver this greeting in Bahasa. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi dan salam sejahtera untuk kita semua. Pertama-tama marilah kita mengucapkan puji dan syukur kehadirat Allah Subhanahu wa taala, Tuhan yang Maha Esa, karena atas izinnya pada hari ini kita dapat bergabung bersama-sama untuk mengikuti kegiatan seminar internasional yang diselenggarakan oleh Pasca Sarjana dengan tema The Second International Conference on Science and Technology Application atau ICOSTA dengan tema Disruptive Trends of Science and Technology Industrial Revolution 4.0 Era. Para hadirin yang saya hormati, perkembangan ilmu pengetahuan dan teknologi telah mengubah dunia sebagaimana revolusi generasi pertama melahirkan sejarah ketika tenaga manusia dan hewan digantikan oleh kemunculan mesin. Salah satunya adalah kemunculan mesin uap pada abad ke-18. Berikutnya pada revolusi industri generasi kedua ditandai dengan kemunculan pembangkit tenaga listrik dan motor penggerak. Pertemuan ini memicu kemunculan pesawat telepon, mobil, pesawat terbang, dan lain-lain yang mengubah wajah dunia secara signifikan. Kemudian revolusi industri generasi ketiga ditandai dengan kemunculan teknologi dan digital dan internet. Tentu perubahan dunia kini tengah memasuki era revolusi industri 4.0 atau revolusi industri dunia keempat, di mana teknologi informasi telah menjadi basis dalam kehidupan manusia. Segala hal menjadi tanpa batas dengan penggunaan daya komputasi dan data yang tidak terbatas karena dipengaruhi oleh perkembangan internet dan teknologi digital yang masif sebagai tulang punggung pergerakan dan konektivitas manusia dan mesin. Era ini juga mendisrupsi berbagai aktivitas manusia, termasuk di dalamnya bidang ilmu pengetahuan dan teknologi, serta pendidikan tinggi. Era industri 4.0 akan terus menghadirkan banyak perubahan yang tidak bisa dibendung. Karena itu, dunia pendidikan perlu berupaya maksimal dan lebih gencar memberi pemahaman kepada mahasiswa, kepada semua elemen masyarakat tentang hakikat era industri 4.0 dengan segala konsekuensi logisnya. Langkah ini penting karena belum banyak berminat memahami industri 4.0. Masyarakat memang sudah melakoni beberapa perubahan itu, tetapi kepedulian pada tantangan di era digitalisasi dan otomatisasi sekarang ini pun terbilang sangat minim. In this moment, I would like to thank from Professor Dr. Jakropang Kayakau, Associate Professor Sirprapa Kayajaing PhD, Profesor TS Dr. Hajah Anitawati Muhammad Lukman, and Dr. Engineer Hendro Cahyono, DEA. Terima kasih Bapak Ibu keynote speaker, Bapak Ketua Senat, para Wakil Rektor, Dekan, Direktur Pascasarjana, Ketua Lembaga, dan seluruh peserta seminar internasional di dalam jaringan ini. Melalui forum ilmiah yang terhormat ini, saya mengajak kita semua, seluruh sivitas akademika Universitas Negeri Medan, terus berupaya dan bahu-membahu bersinergi dalam meningkatkan dan menghasilkan karya ilmiah yang sejalan dengan tema-tema mutakhir saat ini, serta mempublikasikannya ke jurnal nasional dan internasional berreputasi. Saya mengucapkan selamat berseminar, semoga kegiatan bermanfaat untuk kita semuanya dan menambah wawasan serta pengalaman bagi kita bersama. Akhirnya, dengan mengucapkan Bismillahirrahmanirrahim, disaksikan oleh Allah Subhanahu wa Ta'ala, Tuhan yang Maha Esa, dan seluruh yang berhadir, the Second International Conference on Science and Technology Application dengan tema Disruptive Trends of Science and Technology Industrial Revolution 4.0 Era, saya buka secara resmi. Demikian sambutan ini saya sampaikan. Terima kasih atas segala perhatian. Wassalamualaikum warahmatullahi wabarakatuh.
Terima kasih Bapak Rektor. Well, ladies and gentlemen, before moving to the further agenda, we continue to the photo session. We would like you to be ready on the camera of your screen. Hadirin yang berbahagia, acara berikutnya adalah berfoto bersama. Kami mohon seluruh hadiran untuk mengaktifkan kamera pada layar monitor masing-masing. Baik, saya menghitung 1, 2, 3. Okay, thank you very much for everyone. Well, we have already completed the opening ceremony of this conference. Okay, then next, ladies and gentlemen, now this is the high time for us to listen to our keynote speakers. Without further ado, now please help me welcome our first keynote speaker, Professor Dr. Jakrapong Kakao from Nakhon Pathom Rajabat University, and the second keynote speaker, Sri Prapa Kajang, PhD from Chiang Mai University. And for this occasion, I would like to invite Bapak Dr. Rahmat Hussein, MED, to moderate this session. Well, Bapak Rahmat, time is yours.
Okay, thank you, Ibu Cecilia. Ladies and gentlemen, sorry. Yeah, before we start the session, okay, let me introduce our distinguished keynote speaker, Professor Jakrapong Hekau, who received PhD degree in physics from Mongkut King University of Technology, Thonburi, Thailand in 2008. Through his academic career, his research interest involved glass scintillators, electrochemic dope in glasses for luminescence and scintillator applications, color glasses, radiation shielding glasses, gamma and neutron, natural gemstones enhancements, and imitation jewelry from glasses. His research on imitation jewelry from glasses has been awarded by several national organizations. Some of them have been awarded the Best Innovation Award by the 43rd International Exhibition of Innovation of Geneva, Switzerland, the Medaille d'Argent Silver Medal, Silver Medal in 2015, and Seoul International Invention Fair in 2016. Recently, he also has awarded by National Research Council of Thailand in 2017 from research project development of lead-free glass for radiation shielding material. Okay, currently he is the Professor of Physics and Director of the Center of Excellence in Glass Technology and Material Science, CEGM, Nakhon Phanom Ratchabad University, NPRU, Thailand. He has handled more than 75 research projects in glass science and technology, radiation physics, and gemstone enhancement. He also is a member of AMORE Collaboration Advanced Molybdenum-Based Rare Experiment to Search Mass of Neutrons, IBS Korea. He has published around 433 papers in international journals, 3,205 station and high index 30. Now, let's welcome Professor Jakaprong to present his paper. Time is yours for 30 minutes to present your article. Please, Professor.
Thank you so much, Professor. Okay, let me share my screen first and what shall I do, please? Okay. Okay, can you see my screen?
Yes, Prof. Yes.
Okay, so okay, let me start my presentation. I have the 45 minutes, right? Include questions. It is a good morning, my friends and colleagues and all academics in Medan and Indonesia. I am Jakrapong Keo Khao. Actually, I visit Indonesia, especially Medan, every year. But this year, because of the virus situation, anyway, I can, not only I can, all of us, we can not make international trips now. So that is online talk is the one way to discussion and exchange our research. So today, my presentation topic is X-ray, proton, and photoluminescent behavior of samarium dope high density tungsten gadolinium borate scintillating glass. So this is my topics. My topic is let me introduce, take time for introduce our groups in NPRU about glass laboratories in Nakhon Phanom Ratchabad University. And next, I will give a concept of the glass materials, then lanthanide 3+ ion and their special properties. Because of today, I will talk only the samarium 3+ dope in the tungsten gadolinium borate. So next topic is about samariums and then conclusion and possibility for any application. So this is my Asia map and where we do where are we in class lab in Thailand. Actually, from the left picture, you can see here, Nakhon Pathom province is just west from Bangkok, around 1 or 1.5 hours by car. Just around 60 up to 70 kilometers from Bangkok. That is not too far. So Nakhon Pathom is not too big city, but very close to Bangkok. From Bangkok to everywhere, from our colleagues slider to Osaka, just 4.5. Actually, Medan is very close. Medan is take just only 1 hour and 45 minutes from Bangkok by direct flight. Jakarta is 3.5 hours. It's so far compared with the Medan. Medan is the easiest way to go to the Indonesia from Bangkok, and cheap ticket, not too expensive. So this is our international collaboration. You can see we have the many colleagues and friends for collaborations from Russia, India, Turkey, Japan, Vietnam, and New Zealand, Thai, Myanmar, and in ASEAN, many in Indonesia, like the Dr. Astel in UNIMED. Professor Mitra Dijaman from ITB and somewhere in Lampung, I don't sure. ITS maybe, not ITS. Sorry, but ITB, and Dr. Ella and Dr. Melania from ITS in Surabaya. We also have the good collaboration and published some paper together already. So this is my good memory in Medan some time ago, because I visit many times. Some picture like in the restaurant, in the AIST conference 2 years ago, 3 years ago, and last year, Dr. Astel he was a rain ICAPMA in Medan, and this is a very my good memory and exotic trips on the lake and somewhere else. Please see the picture. I don't sure the name, but we take a big boat and cross the beautiful lake and arrive in the some village, historical village, and so beautiful one. So this is a member in our group. We have 13 faculty members in our class lab. So, and we divide people into the 3 groups. First, these 4 people in the left side, they work on the syndicate class and industrial-based research group. That means they work on the problem from the industrial part. They work for develop new materials for industry. They don't focus much publication, just for solve the problem. Anyway, we can get some funding from industry too. So second one is a very academic. They work on the luminescent glass research group, like the phosphate glass, borate, oxyfluoride, and telluride. So this kind of people, they work on some photonics materials and scintillation materials. And last group is a nuclear and radiation physics research group. Head group is Dr. Puntipon, and they work on the radiation physics and the radiation shielding characterization, and also scintillation property of materials. This is our member now. We have 11 PhD. One is Indonesia. This is Shayani. She comes from Medan. And this is Eka from ITB. And 8 master student and some Thai student and 2 researcher and 1 visiting research professor. Actually, Dr. Raja, he just went back to India in this year because of the virus situation, but he will back next year. This is our members. You can see we produce 18 PhD and 8 master now. So this is a list of our instrument. We have the many class furnace, XRD, FTIR, XRF, and many camera, spectrometer, and scintillation materials, and software for calculation of the interaction of photon with matters. Not only that, we also have the optical and instrument materials like the FB refractometer, UV visible NIR, photoluminescent, X-ray induced luminescent, decay time measurement machines, electroluminescent software. And also we have the densitometers just for density of material measurements, ultrasonic fluorometers to measure the ultrasonic, and you can calculate any mechanical properties of the materials, and micro-wiggle hardness and mole hardness tester. This instrument is also available in our groups, and welcome for Indonesian researcher and colleagues to use that one. You just send some samples sometime. Please contact me or contact Dr. Astel, that's fine. We have to talk about the research collaboration, and we can do something and publish paper together. So this is our research backgrounds. If you use the bibliometric analysis from the Scopus, and you work on the class at luminescent from Scopus in the last 5 years, we have the most publication now. And not only that, in last 5 years, in case of in field of the material science in Thailand, we have the top publication also on this. And this is the background in Scopus and ISI. Of course, publication is not the most important for research, but actually, if you have published more, that means you did many research, and your experience is more and more and more. What I want to tell you, I mean, if you want to do real research with the industry part or with the company, you have a good background. Sorry, you need a good background. You need a good skill. So new PhD, sometimes they cannot because they don't have any experience. So publication is a one way. You focus more in academic. You take time in academic for practice yourself. Then after that, you are very professional in some research field, and then company will come and talk with you. That is a way to work with the company, and you can solve any problem because you have background. In my case, for example, I work with many class research for a long time, and now we can do with industry well. So let me talk about the advanced material application for emission-based in class. I am focusing on only the emission-based, like the laser materials. Glass also can apply for laser materials, like in the nuclear fusion experiment, they use the phosphate glass for laser medium, solid-state lighting materials, fiber optics, scintillation materials, and anyway, many applications for emission-based glass. And please see only this. In case of the radiation detection materials, is many applications like in the high energy physics, radiation monitoring, X-ray imaging in medical application, in the homeland securities, any X-ray for securities, and in the neutron imaging for protection, for security. This is you need some material that can change your radiation to some signal. In this case of glass, you change radiation to the light signal. Some of the radiation detector material, they change radiation signal to the electrical signal, but in our case we change to light signal. So this is the definition of glass. I take one of the definition. Glass is an inorganic production of the fusion which has been cooled to a rigid condition without crystallizing. That means glass is a kind of the amorphous materials. Let me talk again. Glass is a kind of amorphous materials. But we have another amorphous material also. We have other amorphous material also. Please see this slide, and you can see how you can produce glass by technique we call melt quenching. If you melt the materials or glass former above their melting point, there will be perfect melt, completely melt. And then when you have cool down, you have to weigh. One, this is line. You can see my arrow. This line you get glass because you cool very fast. But if you come to this line and temperature is not changed and going down again, you get crystal. That means you have to cool very fast before atom can be arranged in your materials. So you get a amorphous material. So this light picture, you can see the crystalline solid. You can see some pattern in atoms. Sorry, in your materials, in molecule or atoms. But in case of the glass or amorphous solid, you cannot see any pattern in your atoms. You can say that this is atom is a randomized in the amorphous structure or glass structure. Sometimes, actually, glass is a subset of amorphous materials. But sometimes, some textbook, they use what glassy state. That's mean amorphous one. So in case of the chemicals, you can divide you can categorize compound into the three group. One is a glass former, the green color. Glass former, that means this oxide can be after melt above their melting point and quench in appropriate condition. They can change to be a glass, I mean transparent materials without atomic arrangement. But if that chemical above their melting point, melting above their melting point and quench, sometimes they cannot, not sometimes, some material never change to be a glass. That is not glass former. So that's mean we have very limited glass former. Very good. The good example is a silicon dioxide. Sometimes we call silicate. Boron oxide, phosphorus oxide, tellurium oxide, and germanium oxide. Tellurium and germanium is more difficult. The most popular one is silicon, boron, and phosphorus oxide. We call silicate, borate, phosphate, telluride, and germanate glass, for example. If that chemical go melt with the glass former but break glass former bond, we call modifier. Most of this chemical is alkali, lithium, sodium, potassium, and so on. But if some chemical break glass former bond but reborn again with the oxygen, we call intermediate. The good example is aluminum oxide, and make your glass is stronger. So that means you have the former, modifier, and intermediate. A former is general one. So if they are not former, it's not possible to be a former in any condition. But modifier and intermediate, not, it is depend on the fabrication condition, melting point, concentration of the chemicals, many properties. Many conditions. So that's mean one chemicals, sometimes they act as a modifier, sometimes they act as intermediate. Is possible in different preparing conditions. So let's talk about the lanthanide. Why we choose lanthanide in this work? Because the lanthanide is very sharp, luminescent, and intense, and stable in different holes. What does it mean? Stable in different hosts? It means in any host, glass, plastic, ceramic, crystal, solution. Lanthanide is also show the same emission pattern, very similar, not same, sorry, very similar emission pattern. And in this work, we focus on the samarium that will be emit orange color at 600 nanometers, and decay time is around millisecond. So you can see from this slide why the luminescence from the lanthanide is stable, because lanthanide, I am talking about the only 3+. Okay, let me I'll tell you again. I am talking about only lanthanide T+, 3+, and in the T+ case, if there are electron is in the F block, valence electron in the F block will be shielded by 5s and p. So that means very weakly affected by surrounding host ion. But in case of the metal, is very strongly affected by host ion. Or for example, if you dope transition ion to the glass or to any host, if you change host, pattern of luminescence may be changed, shape may be changed, profile of the spectrum may be changed. But if lanthanide is not much changed, it's very similar. So this is a for good example between blue line is a niobium, is a lanthanide 3+ ion, and red one is a chromium one, is a D block. You can see the absorption is sharp and very broad between lanthanide and transition one. So in this class, let me focus on the X-ray and neutron detection. Our class, we have the tungsten, boron, and gadolinium. Because this property, high density of tungsten, good transparent in boron, good interaction with the X-ray and neutron is in tungsten and gadolinium, and boron for neutron also, and gadolinium for neutron also. And we have there is energy transfer from gadolinium ion also, and strong emission from samarium. This is a good combination that we design for X-ray. Why we need a high density? Because in case of the X-ray detection or scintillation detection and we need high density material as much as possible. So this is a glass former. This paper is already published in I don't know, in somewhere else from our group last year. So this is a glass preparation. You can see you mix, melt, and quench, and cut and polish. You can get this one, glass fabrication and glass sample. Okay, you can see from this. This is the melt quenching technique. Okay, let's see another one. In the picture is my research assistant, and yeah, he wear the protection suit. Okay, so this is a instrument in this work. We use the many instrument. Let me skip this work. Okay, this slide just standard instrument for characterization. Let's focus on the result. In our class, tungsten, gadolinium, boron, doped samarium, we got the perfect amorphous one from the XRD pattern, and density is keep going up and molar volume is going down. So you can see our density is 6.1 is the highest. It's a so high glass density. You can see from literature, not much this kind of the high density like that in any glass sample in the literature. So we have the very high one. And from the absorption spectra, you can see many peaks, but all peak is samarium T plus ion in glass, and you can define the energy level of the absorption by this picture. And absorption band is increased with increased samarium concentration. Please remind that we cut and polish glass to the same thickness for this measurement. And for the excitation spectra, for emission at 600, we found the highest emission is 403. And gadolinium is around 275. You can see from the orange color. And we also found the tungsten charge transfer band, very broad, around near 311. So we try to excite in gadolinium level, tungsten charge transfer level, and samarium level, and see what happened in their emission. Let's see this slide. We excite at the gadolinium level, we excite at the tungsten charge transfer level, and we excite at the samarium directly level. So you can see the similar pattern. But in case of the gadolinium, you can see emission at 310 is keep going down when samarium concentration is higher concentration. That means some energy transfer is happened. Sorry. This is this is a concentration quenching. What is the appropriate concentration for the best emission? In this work, we get 1% mole of the samarium oxide, and the energy level to explain all emission is shown in the right picture. If you excite at gadolinium is 275, and then energy is they have the non-radiative radiation, and energy and emission is happen for gadolinium is 311. Anyway, there is energy transfer to samarium ion also, and you can see this transfer and show some show samarium emission, foam emission, but the best emission is, the main emission is 600. It's orange color. Decay time is around millisecond region. Is our general trends and general value of the samarium is around millisecond, and decay time keep decreasing with higher samarium concentration is because of the samarium transfer energy to samarium. We call cross relaxation. Please remind, cross relaxation is also the same ion, but energy transfer is come from the another ion like the gadoliniums. We use different words. And from the IH fitting, the cross section between samarium donor and samarium acceptor in glass is show dipole interaction, and we can calculate Q value, just energy transfer parameter for this class also. That means there is a possibility of the cross relaxation between samarium ion increase with higher concentration of the samarium oxide. Please remind, this calculation just for samarium and samarium, not related with the gadolinium. It's different. And this is a temperature dependence luminescence. From temperature dependence, we excite by the 266 laser from the room temperature down to 10 kelvins, and we found that if temperature is down to 10 kelvin, light is increasing around 3.7 times. That means you can get better light or more light 3 times, let's say near to 4 times in low temperature, because phonon vibration is less in low temperatures. So you can see the color of emission. This show orange by CIE plotting, and this is a pic. In the picture is a UV lamp, and in video file you can see the UV excitation and laser excitation is a 405 for laser, and UV is 365, and you get the very beautiful orange color. Where is my? Okay, let's see. Sorry, what happened? Okay, this is laser excitation. This is UV lamp excitation. Good. And this is X-ray and optical luminescence. From the X-ray excitation, you get the same emission pattern, and quenching is the same. It's a 1% mode. I mean, the best concentration for highest emission is a 1% mode, and you get the same pattern. But one thing different is 647 is higher than 600 emission. That is a very interesting result. We cannot explain that now, but this is very interesting because in case of samarium, generally 600 is the best one. And this is useful information, and this is decay time. You can find decay time, and it's around 0.2 millisecond for decay time. This decay time number is similar to the photoluminescent decay time, but this is using the X-ray excitation, pulse X-ray excitation. And this is a proton luminescence. It's also the same. When we excite by radiation, the 650 nanometer peak is higher than 600. It's also not general one. Very interesting result for proton. But from the proton result, that means you can get emission also from proton and X-ray from the last previous slide. This is a conclusion. So we success to develop gadolinium tungsten borate glass with very high density, around 6.1. Absorption is show good samarium 3+ in glass, and emission is show main peak is 600, but for X-ray and proton is 650. Very interesting. Quenching is around 1% mole. That means the best concentration is a 1% mole for the best emission. From the temperature dependence, you can see that light is coming more 4 times when temperature is down to 10 Kelvin. In the other hand, you can say that your light is decreased when temperature is rising, because this is we call thermal quenching effects. And for decay time for photo X-ray is a similar one, and color of emission is orange. Application possibility is X-ray detection materials in imaging inspection system, medical diagnosis, industry defect inspection, and many security checking, because you can get the light from proton and X-ray excitation. Thank you very much for your attention. This picture I took in some airport in Indonesia. Sorry, I forgot it somewhere. Thank you, everyone. That's all.
Oh, okay. Thank you very much, Professor Jakaprong. Sorry, dear participants. In fact, we have still time, yeah, for you to ask questions related to professor's presentation. Now, I would like you to ask questions related to his article, please. Or should you raise questions directly to Professor Jakarapong, please?
Yes, please.
Okay, there is one question, Professor Jakarapong. Now, from Pak Elmanani, he would like to ask you how to find estimation of regression.
What is regression? I don't understand. I mean, in my class?
Yeah, maybe Professor Jakrapong.
Yeah.
Yes.
Yeah,
Pak Elmanani, would you please define what you mean by this regression? Because Professor Jakrapong asked you about this. Yeah, because your question is how to find estimation of regression. Okay, would you please clarify a bit about your terms related to the word regression, please? Excuse me, Mr. Jakrapong, please
Yes,
open
please.
the slide 30. I'm sorry, 36.
36.
Yes.
This one?
No. You have regression. How to ask you about estimate time. This is yes. Time is every yes. How to
Is this
estimate?
this picture? This decay time?
Yes.
Okay. You just use the simple software in the origin.
Okay.
That's it. So
Yeah.
actually, this decay time is data is come from the signal from oscilloscope.
Yes.
So we excite by the pulse X-ray excitation. The pulse rate is around 20 nanosecond pulse X-ray. Shoot by pulse. That means X-ray come not continuous. So in the principle of the X-ray pulse excitation to decay time measurement, pulse should be shorter than decay time. That is a one thing. So then you can use your electronics like the oscilloscope to measure one. After that, you get the decay profile. And nature of decay profile is exponential, but sometimes it's not single exponential. Sometimes there is one more than component, like the 2-component decay time, 3-component decay time. So you have to fit by software again. So what is the software you use? You just use the origin one, it's simple one, and you fit that curve and you can get the decay time values. Yeah, that is the answer. Thank you so much.
Okay. Thank you. Yeah. Okay, thank you, Professor. Now there is another question for you. Yeah, from Dewi Wulandari. The intensity of matter depend on the level of energy excitation. Why samarium SM is the best method for application?
No, yes. Actually, intensity of emission is depend on many factors. One thing is of course, is depend on the excitation, but this is in experimental values. Experimental condition. If you change the excitation source, for example, you change from the xenon lamp, you change to the laser, you change to the X-ray, you change to the high intensity X-ray, you change to the very high intensity X-ray. Of course, emission is changed, but you can choose. That is the point. In case of the property of the material, I mean in glass, so in the principle, emission intensity is depend on concentration of samarium. But if you have too much concentration, let's say too high concentration, there is one effect we call concentration quenching. Light emission will be decreased when you dope too much. Light emission will be decreased when you dope too much. Why? Because of, you can see from this calculation, energy transfer parameter may be more. Maybe come from the cross relaxation, something like that. So it's mean if in case of the samarium doping, it depends on samarium concentration, but you have to find the best optimized concentration from concentration quenching effects. Anyway, not only that, it depends on quality of your material, like the optical quality, how transparent, do you have any effect, do you have any imperfect in your glass media, maybe it's effect to your luminescence also. And the question is, why samarium? Because samarium have their signatures. They emit orange in 600. That is a point. And when light is coming 600 nanometer, you can use your photo detection device like the PMT or photodiode to detect in the range that you need. So that is a point for samariums. Thank you.
Okay, thank you, Prof.
Okay, thank you. Now, is there
Yeah.
anybody who would like to ask another question?
Can I ask question?
Yes, Professor Nita. Yes, directly, please.
Hi, good morning, Prof. Chakrapong. I'm from Malaysia. Yeah.
Morning.
Okay. It's interesting about glass. I've watched a few videos about the future of glass and technology, where the use of glass in the future is actually a lot of technology can be embedded into glass technology. Is your work has any geared to that? I mean, yeah, the use of glass for technology. I mean ICT.
In ICT?
Yeah. I mean, I've seen a lot of videos about it. I mean, the future of glass.
Yeah.
Mm-mm.
Yeah, as far as I know, we use for the telecommunication as a fiber optic materials. This is a glass materials. That's why you can send the light signal very fast using light signal for your internet. That is a one point. Yeah, for ICT.
Okay. Understand.
Yeah, this is okay. Hope this is okay for you.
I'm just curious because there's a lot of videos I watch about the future of glass and technology, and it's very interesting.
Yeah, not only samarium. Actually, samarium you can use as the line in the undersea communication. But in case of the another doping like the erbium, you can use as the optical amplifiers. Optical amplifier, that means you can amplify light signal, and then you can send light is longer distance. Please remind, light is your signal, not electron, not current. So if light is your signal, everything is faster. In case of you want to send electron signal or a current signal, you need the copper wire for some, or for example. But in case of you want to send light signal, you need fiber optics, and fiber optic is made from glass. That is the point. You cannot make fiber optic from the single crystal. You cannot make a good quality of fiber optic from the plastic. You need glass in the core. Yeah, because the transparency is better.
Thank you for your answer.
Thank you.
Okay, thank you, Prof. Nita. Okay, thank you, Professor Chakrapong. Okay, all audience. Yeah, that is the end of our session with the great ideas about glass from Professor Chakrapong article. Okay, Professor Chakrapong, before we end the session, I would like just to remind you, if you have the article, would you please send it to the committee, please? Yeah, the article. Send.
Sorry, Mr. Rahmat.
Oh yes, please, Professor Borno.
One question again.
Oh yes. There is one more question to you, Professor.
Mr. Chakrapong. Excuse me, Mr. Chakrapong. What instrument that you use to measure of decay time?
Decay time. Yeah. Actually, decay time, the principle of decay time measurement, you need two things. One is the excitation sort. Please remind, decay time is just number of electron from upper state to lower state. If we consider the equation of decay time will be exponential, but sometimes it's not perfect one. Sometimes it's not single one. You need the excitation sort is one thing. What is the excitation sort? Light, ultraviolet, xenon lamp, laser, X-ray, proton, any energies, but should be plus one, not continuous one. Plus one, that means you have to shoot plus by plus, and then you need to have the plus rate that faster than your decay time. So then after that, when you detect light from that emission, your material should be have emission. You need the electronic part that can measure decay time in the range of your decay time. simple one is the oscilloscope. That's it. But if you want to buy the expensive machine, you can use the photoluminescent machine. They have this function. That's it also.
Thank you very much.
Yeah.
Okay, thank you very much. Yeah.
Thank you.
Yeah, thank you very much for your response to Professor Bornok. This is, I think, the end of your session, Professor. Very great discussion, yeah, about this glass. Hopefully that we'll meet again in someday. And then if you have still time, you may come again, yeah, for the parallel sessions in this afternoon session. Yeah, but you may also stay here to listen to our next keynote speakers. Okay, thank you for Professor Jakrapong. We would like to give a big applause to him. Yeah. Well, audience.
Thank you so much.
Yes, well, audience. Now we would like to invite the next keynote speakers, our distinguished Associate Professor Dr. Sri Prapa Wajeng. Yes, Professor Sri Prapa. Okay, now before his presentation, let me introduce a bit about him. Yeah. Associate Professor Dr. Sri Prapa Wajeng, yeah, was born in 1985, still young, yeah, very potential. Bachelor of Science in Radiology Technology, Narshan University, Pitsanoluk, 2008. Master of Science, Medical Radiation Sciences, Chiang Mai University in 2012. Doctor of Philosophy, Biomedical Science in Chiang Mai University, 2015. And Radiological Technology at Samiti Fence Sriracha Hospital, and was also Radiological Technology at Bangkok Phitsanulok Hospital. Yeah. He has numerous of Scopus publications, yeah, around 28 articles, yeah, in the Scopus Index, and then he has also actively presenting in national and conference international. Without further ado, now we would like to invite Professor to present his article. Around 30 minutes, time is yours, Prof.
Okay. Good morning, everyone. My name is Nivapha Gyatang from Chiang Mai University. My topic work about the X-ray radiation of cerium oxide, dope borosilicate, and bioluminescence characterizations. Before I begin my previous works, I will invite my universities. My university stay at the north of Thailand, near Myanmar, and the western now is about 25 to 20 to 25 degrees Celsius, a little bit cool. And if you want to touch the cool weather, you can join as my faculties, and very warm welcomes. And now my topics that I present before, that X-ray radiation shootings of cerium oxide, dope borosilicate gas, and their luminescence characterizations. My contents about 5 topics at your right hand side. And the first one is at my works, use radiations for radiation shootings, for radiation in diagnostics for patients. In our life, we use radiations for in medicals, in industries, in agriculture, and in science. We use radiations in our life for everything, such as in my fields. I use radiations for diagnosis patients, for how to know the chemicals from them. And now in my fields, I forgot active fields that the first one is diagnostics. Diagnostics is give the chemicals patient that you know if you begin the when you feel ill or have a fracture in your body, you can use the X-ray for diagnosis. And the second is therapy. Therapy is used for the cure the cancers. And the next one is nuclear medicines. You can be reject some medicines for detect the cancers in your bodies. That's one in my fields. Use the radiations for treatment and for diagnosis. In my works is use the X-ray for diagnosis. This one show the sums of medicine, sum of instruments. That's one I use the X-ray for diagnosis, such as the X-ray, general X-ray for diagnosis, or the computer radiographies or CT scan for cross sections, radiations, imagings, and I used some machine for detect your mammogram for finding the breast cancer in women. This one, when I use the radiations, how I protect the radiations. That's one the sums of department give the rules for T rule. They is called ALALA. They give rules by national is called NCRP. That one is a national causes on radiation protection and measurements. This ALALA is called as low as reasonably achievable, like this. What is about the rule? The rule is you get when you work, you used to very less time, and for the distance is if your works with the radiations, you must to as far as you can for less radiation dose. But if you didn't get two topics before, you find something for protections from the radiation. That one is called the shielding. The radiation shieldings in my works are developed from glass sample. In my works at the hospital, I use all of them. It's made from lead. It's such as the lead cap, lead gases, lead golf, gonad shields, lead upons, and thyroid shield. Everything is made from lead, but a very high toxicity in the preparing process. Now I find some things or some medical for give the less toxicities. That's one in my works. I focus on radiations gas. That is very important because when I work at the control state, I want to watch the patient inside the room. For patient don't move and patient inside room is everything is normal because it's for the diagnosis very important for patient and for technicians. That's why I select the glass. But in the glass is radiations department use the lead very that I present before is very high toxicities. I find some chemical for get it. And some of my works for this work I select cerium oxides and I select some chemicals for give the luminescence properties and radiation shieldings. That's one I select cerium oxide for added is my gas. Before why I select this, I will explain about the luminescence. Luminescence is the emit light from the excited state before they back to the ground state and give luminescence, some luminescence like this, and can separate for two types of luminescence is fluorescence and phosphorescence. My work try to develop with fluorescence and phosphorescence also. Why I use or select gas for radiation shielding and luminescent materials. That one is high durability, easy to preparations. That Professor Jakapong tell you before, and high chemical stabilities, can be recyclable. Is that mean that if you get some gas materials and if you didn't want it, you can melt it again and you get new shape and new size. That's one, and can be easy in for transparencies. That one is my gas formula in my research. I select very long chemical compositions. I use it 55 silicon oxide, 13 boron oxide, 1 aluminum oxide, 4.5 barium oxide, 6.3 calcium oxide, and 0.2 antimony oxide, 20 sodium oxide, and X is cerium oxide, and mix them all of chemicals and get the gas doped in gas sample is I call it the cerium oxide doped in gas samples. And then properties of compositions. For the durability is I select this chemical is silicon, aluminum, and boron, and reduce the melt quenching for my gas is sodium, aluminum, and boron in oxide concentrations. For the thermal stability is antimony, and high transparency is barium oxide. And barium oxide can be give the radiation shielding properties. And gas former, this is very important for gas forming. For gas structure is silicon and boron is called the silicobolate gas or borosilicate gas. And next one is this is standard temperature shock is calcium oxide. That's one of chemical that I select. That in market space and in the another composition, another works, they select some of chemicals for select to give the luminescence materials or radiation shielding materials, such as molybdenum, rhodium, tin, antimony, barium, tungsten, lead, and bismuth. These are X chemical that's very popular for use or added for radiation shieldings. And in my work focus at the below size of periodic table, I select the cerium in cerium oxide. The cerium in cerium oxide is good property for luminescence, and I apply for radiation shieldings for balance the studies. That one is my properties of compositions. Why I select the cerium oxide for added or dope in my gas formula, because it's highly effective indeed and can be UV protections and give the luminescence properties. Some of them, when I get the gas samples, I prepare the gas samples and gas characterizations. Use melt quenching technique at 1,400 degrees Celsius for meltings. And after that, when I get the gas samples, I try to characterizations them with physical properties, optical property, luminescence properties, and some of radiation shielding properties. That one is shown of my gas formulas. I assume at the X cerium oxide, I vary about the concentration at 5 concentration between 1 to 5 mole %. I change X at the cerium oxide in the gas formula and guess this one. The colors is changed more in the bar when the dope or added the cerium oxides more concentrations. That's one when I get the gas samples from the last slide, I bring it and find some physical property by using the densities that calculate by Archimedes method. The trains of my density is showed same the theory value that when the concentrations of cerium oxide increase, the density is increased and show in the graph at the right hand side. Next one of my work is optical property is your UV visibles NIR, and finding sums of can be transparent or not, because it's my work. If I bring to discard for radiation shieldings, I find some trend to go transparent or not. That's one show the glass absorption from the right hand side that you see. The next one, when I get some radiation absorption, I find some photoluminescence from the excitation spectra and emission spectra. On the left-hand side is excitation spectra. Under emission at 341 nanometers. That's the one I select 341 for excited in the show the emission spectra that show the at the strongest peak at 390 nanometers at the right hand side. This one is the cerium T plus ion of the cerium oxide. That one, after I get the all of luminescence properties, I find the radiation shieldings. That's one experiment set up. I use the cadmium telluride detector, CDTE detectors for radiation detections. After that, I try to set up my experiment. That one, I put my glass samples on the detectors, and in front of in the top is show the X-ray machine, and in the left hand side is show the technique. This technique is used for diagnostics in the hospital for use the patient give the organ and imaging like this. And after that, I put the X-ray, and X-ray is out, and finding sums of how to the radiation can be detections and the intensities of radiation. For in my work, when I export the radiations past the gas samples, the radiation detection detects the radiations. When I put the gas sample, the radiation will less than. And when I get off my gas samples, I find some of material for this one is called the standard material in the X-ray department. That's when I select the concrete big commercial windows, X-ray windows, and compare with my gas is work or not by the same technique for the diagnostics radiations. And then find sums of the radiation shielding material is half value layers, linear attenuations, 10 value layers, and mean free path. The results of my work show the linear attenuation is the same the theoretical that you see the concentrations of gas increase. It's called mu. Linear attenuation is mu. Mu is increased too. When the KVP is the radiation technique, is called the KVP, kilo peak voltage. That's when it increased. The mu is decreased. The next one is half value layers. Half value layers or HVL. Each one is if you give the radiation, find some material for attenuate the radiation in the half, 1 in 2. That's one I use the formula in the right hand side. The result show that the concentrations of gas increase, HVL decrease, KVP technique is increased. Also HVL increase too at the same 30 halls. That is the 10 value layers or TVL. 10 value layer is mean the when you give the radiations, you'll find some material for attenuation in 1 in 10 radiation dose. The tens of my work is the concentration increase 10 value layers is decreased. TVL and TVL is increased. And the next one is mean free path. Mean free path or MFP. Mean free path or MFP is mean that the radiations pass to the material that before we attack some of molecule that show the concentrations of gas increase, MFP is decreased, KVP is increased, and MFP is decreased. As all of composition is the same 10. That's one I compare the half value layers with standard materials. That one I compare with glass, big concrete, and red glass or X-ray shielding windows. That one on the left ball of my work is cerium oxide. Is the trend is increased when the concentration is increased. That show the trends of my work is nearly the less gas. Maybe in the future can be added or doped more concentration for radiation shieldings. And conclusion of my work, the concentrations of gas increase, the Mu's linear attenuation is increased, while MFP, HVL, and TVL is decreased. At the same time, when concentrations of gas decrease, Mu is increased and MFP, HVL, and TVL is decreased. My work is focused just only radiation shootings and luminescence of the cerium oxide. But now in the future, I try to develop another compositions or another chemical for give the luminescence property and new radiation shootings. And hope you join with my country in the future, and warm welcome if you want to join at my university, Chiang Mai University. Thank you.
Okay, thank you, Associate Professor Sri Prapa. Yeah, all dear audience, in fact, the professor presented a bit quick, yeah. So we still have much time to discuss about his article. Now, Professor Sri Papa, there is a question from Nur Fazriani. The first one is, borosilicate glass widely applied in laboratories. How is thermal effect of borosilicate glass? Sorry, how is thermal effect of borosilicate glass?
Borosilicate gas that very wide for use in our life, such as the laboratories or in the gas windows, some things, or in gas that you drink some water, they apply from the borosilicate. That thermal effect really is important for these works, because sometimes is the before I get the gas samples, some of gas is crack is mean a broken of gas and difficult for preparing. That is work is I just tell that try and error for get some gas samples. Very difficult for preparing.
Okay, thank you, Rob. Yeah, all audience, maybe I would like to invite you to directly ask to Professor Sri Prapa.
Excuse me?
Yes, please.
Okay, I have a question. It's really interesting topic for me. Luminescence is created by transition from the excited state to the ground state. So based on your experience and your experiment, how to prepare matter has long lifetime luminescence, and what factor that influence the process to prepare the matter? Thank you.
For my work is cerium oxide is limited of these works because the machine. Some of problem of my work is the lifetime of cerium oxide is must to use the perfect and high abilities of the machine for finding the lifetime. This one is just very limited of this work. When I get the laboratory for this, I finding many problem on this work and try to practice and try to develop in the future more. That's one I just only get the absorptions and photoluminescence, just only this. Thank you.
Okay, do you still have any questions, please?
Excuse me, Dr. Ahmad Hussein.
Yes, please, Dr. Rajagugu.
Okay, thank you for the moderator. Hello, Dr. Kai Jang.
Yeah.
Yeah, I think your presentation is very interesting to discuss about the radiation shielding, and very good the presentation. But I want to ask for one thing about what happened in the structure glass or in your glass if the cerium concentration increase to the composition. What happened in the maybe you can explain about the physics properties, or maybe still have applied to the radiation shielding if they increase the composition of cerium oxide. Thank you.
I will develop or add that more concentrations of cerium oxide for radiation shielding in the future. Because now is the prototypes or the lab setup. That's one is I just only get for 5 gas sample is for very difficult for preparing and many problem all this. This one is begin step for cerium oxide for me for develop the radiation shieldings and try to practice about the radiation shieldings in the futures. Thank you.
Okay, good.
Okay.
Hopefully for your the future project, maybe it can develop again. Thank you.
Okay, thank you. Yeah. All other participants. Okay, Professor Siri Prapa, there is another question for you from Farida Wahyuni. In measurement of X-ray shielding properties, what is the distance between the X-ray tube and the detector or FFD1 set?
Okay, I set up with the patient in the X-ray department about 100 centimeters and put the detectors from the floor about 30 centimeters. Begin the scattering from the floor and from the anothers inside in my detectors. That's one, and put the radiation down and some put the radiation shooting in front of the detectors about 50 centimeters. Half between tubes and detector like this is about 30 centimeters. Half and half. For good geometry in the X-notice radiation setup.
Okay, thank you. Yes, Farida Wayuni, I hope that you've got the ideas, the answers, yeah, perfectly. And then I would like also, still we have time, yeah, for Professor Sri Papa. If you have still more questions related to his article, please. All right, since maybe the question has also a bit related to the previous articles with Professor Zakra Fong, yeah, related to glass also. So some of the questions also have been questions. Now I would like to end the sessions, yeah, to Professor Sri Papa. Okay, now let's give a great applause to Professor Sri Papa for his presentation. Okay, Professor Sri Prapa, if you still have time to join this session, we would like very great if you still here with us. And then I just would like to remind, if you haven't sent the article, would you please submit the article to us that we can share to the audience, Professor. Okay, once again, thank you to Professor Sri Prapa, and then I would like to give this session to the moderator again, to MC or to the committee, please.
Thank you, Bapak Rahmat. Then next, ladies and gentlemen, it is time for us to listen to our third and fourth keynote speakers. Without further ado, now please help me welcome Professor Dr. Hajah Aniwati Muhammad Lokman from Faculty of Computer and Mathematical Sciences, University Technology, Mara, and Dr. Insinyur Hendro Cahyono, DEA, from National Nuclear Energy Agency of Indonesia. And for this occasion, I would like to invite Bapak Mangaratua Simanjorang, MPD, PhD, to moderate this session. Well, Bapak Simanjorang, time is yours.
Thank you, Ibu Cecilia, and thank you for all distinguished participants, especially our keynote speakers, for joining us in this conference. We still have another two experts in this session who will present their thoughts related to their field of expertise. For all participants who would like to ask a question, please later write your question down on the Zoom chat. Okay, our first keynote speaker on this session will be Professor Anitawati Muhammad Lokman from University Technology Mara, UITM. She received her Bachelor of Engineering in Information Engineering from the University of Fukui. In Japan in 1994, and a Master of Science from UITM in 2001. She obtained a PhD in science, specializing in Kansei engineering and emotional user experience. She is the pioneer of Kansei engineering in Malaysia, entrusted with the knowledge by her guru with collaboration in research projects, co-authoring books and research articles, and sharing knowledge transfer in workshops and tutorials in Malaysia and abroad. She has also given keynote address at several international conferences and seminars. With favorable response to Kansei engineering field, she founded the Malaysia Association of Kansei Engineering Malaysia, MAKE, in 2015, and was appointed as the first president. She has gained recognition locally and internationally, and is becoming expert reference in Kansei engineering, emotive web, happiness and well-being, quality of life, and interface and interaction design. She is active in introducing Kansei engineering into diverse fields such as culture and design, social media, public service, robot interaction, and internet application. She has published more than 100 books, journal articles, conference papers. Among recognitions she received were Best Writer Award in 2016, Best Researcher Award in 2017, CHRO Asia's Women Leadership Excellence Awards in 2018, and 2019 Pioneering Woman Leader at the 6th World Women Leadership Congress and Awards for her contribution in pioneering Kansei and effective engineering in Malaysia. In 2018, she successfully hosted the 7th International Conference on Kansei Engineering and Emotion Research in Kuching, Sarawak, Malaysia, in collaboration with KEER International Board and UITM. Professor, as a kind reminder, you will have 30 minutes to present your slides. So we will have 10 minutes later for questions and answer. So without further ado, let us welcome Professor Anitawati. Professor, please, the time is yours.
Right, thank you very much. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone.
Waalaikumsalam.
Hello everyone. Before I begin, let me show you my slides first, yeah?
Thank you, Professor.
Can you see my slides now?
Yes, we can.
All right. Okay, let me begin. First of all, thank you to the moderator, Bapak Dr. Manggara Tuasi Manjarang. I hope I pronounce it correctly. For the long introduction. A very good morning to all honorable guests and ICOSTA 2020 audience. Okay, first of all, I would like to express my sincere thanks to the organizing committee for inviting me to this keynote session. With this new normal we are in, I believe it will bring human experience to another level. Calling the attention to engagement, which also relate to the topic I will bring in today in this keynote session, which is emotional UX, embedding Kansei in designs. Okay. It is very interesting to listen to the previous keynote speakers, but my talk will be more on the science of human experience and IT. Well, before that, I would like to share, I have long experience in system design and development before I joined the academia. Even during that time, my work was about improving systems that facilitates to the good quality of life of workers by improving their work experience. I mean, that is what a computerized system should do, isn't it? By making human lives easier, not more complicated, which caused by many bad experiences and such. So ever since I began my research career, I have always been passionate about improving user experience, be it in daily lives or when interacting with everyday things that enrich human lives. All right, we know that many efforts have been done in the past research involving aspects of human factors, all right? In industrial design, such as car interior or exterior design, clothing design, home appliances, wardrobe, and many more. Or in interface design, such as in website user interface design, a control panel, or even airplane cockpit design. Focus have been given to the ultimate target to improve experience and quality of life of the targeted users. This make people happy, especially in today's new normal where technology is the core to continue with our daily lives. Emotion is always been important. Emotion is about being human. In fact, if we look closely, we don't exist fully without emotion. I mean, if you try to look at your friend next to you, if you have one now, if emotion does not exist in him or her, for instance, then it is an evidence of something is wrong with her or him. You can check it out. Now, why do we talk about emotion? Emotion obviously has become more important than other aspects, such as efficiency and effectiveness, right? As it is important for humans to feel good, which also quickly affects businesses. Because if employees are happy, they tend to work better. They tend to be more productive. Past studies show that employees tend to work better in a working environment or system that make them feel good. On another note, businesses really wants to make customers happy for many reasons, including for retaining loyalty. And of course, customers won't buy anything if they are not happy, isn't it? So emotional design is the concept of how to create designs that evoke emotions, which results in positive user experience. Designers aim to reach users on 3 cognitive levels: visceral, behavioral, and reflective. So users develop only positive associations and sometimes including negative emotions with products, brands, and etc. You can think about this. How do you select clothes that you wear every day? Is it because it is a good fit? Or is it because it's currently trending? I guess it is both. Or for another example, how do you choose to buy a car? By engine's efficiency or looks? I think both again. Because it's basic human nature to get attracted to good-looking things. We all prefer eye-catching and functional over just only functional. Therefore, emotional design is about creating aesthetically pleasing and functional connections between users and the product so that they love using the product and come back to use it again. The word experience in user experience implies the emotions that users go through when they use a product. Depending on a lot of factors, they can be happy, they can be satisfied, they can be frustrated, overjoyed, disappointed, or others by the experience. User can also feel 2 or more emotions while using an app, for instance. In this example, for instance, you can see the faces shown while these people are using their mobile phone to do whatever they do. We can see different types of emotion on their faces. These are caused by the interaction with the phone, or more accurately, the apps on their phones. Any feelings, good or bad, is an emotion. And quite obviously, a product or digital app becomes people's favorite when the users feel joy using it. Therefore, it's only logical that designers must keep this aspect in mind while designing interfaces. Aaron Walter, the author of Designing for Emotion, used Maslow's hierarchy of needs to create the pyramid of user needs. Like Maslow's hierarchy of needs, functional aspects take precedence. But in order to seek fulfillment, one must consider the emotional aspects too. At the bottom of this pyramid, you can see the baseline characteristics. The functionality. Does this product work? Next comes reliability. Is this product reliable? Then usability. Is this product easy to use? And finally, pleasurability. Does this product make us feel good when we use it? So pleasurable products connect with users on an emotional level. And this feature makes them want to use it more and more. But the power of emotion in digital products go beyond creating pleasurable experiences. It makes the experience more memorable, and this drives adoption and sometimes creates new user habits. That is why the best products that we have in our world were designed for emotion. How? We'll see later on this. But look at the trend of job descriptions in IT, for instance. In the past, employees seek for expertise in interaction design and usability expert. But now, they seek for specialists in user experience or UX. Often when you're designing interactions or interfaces, you would think about user experience. And when you are designing user experience, you would think about usability. It's just that now the emphasis is to UX. The role is bigger. Why is it so? Because now experience matters. People want to feel things. People want to be part of the excitement, inspiration, or the dramatic event. They are basically very much about emotions. For example, if we see in the past, handphone had been about communication and connecting people. But now, for instance, iPhone is about being an iPhone user, about the sleekness, about the design, and etc. It is about a statement of saying who you are. We have ISO 9241, a standard covering ergonomics of human-computer interactions, and it has in it a guide for usability. It highlighted on effectiveness. Does it do the right thing, or does it get things done? Efficiency. That is about, does it do that with a minimal effort, mentally and physically? And then satisfaction. Does it make you feel good? And do you feel happy using the system, for instance? The third one, the satisfaction, is all about emotion. That is the way you feel. And this one is often ignored. As Donald Norman, the grand old man of user experience, said, everything has a personality. Everything sends an emotional signal. Even where this was not the intention of the designer, the people who view the website, for instance, infer personalities and experience emotions. But there is no golden rule of designing products that elicit a strong emotional connection among all users. The reason is because human emotional state is constantly changing, and a lot depends on our surroundings, environments, or other factors. Therefore, as designers, our focus should lie on crafting usable and engaging products, which also look aesthetically pleasing. Now the question is how to design emotion into product design. So today I would like to introduce a concept of emotion from Japan called Kansei, a methodology to embed emotion into product design called Kansei engineering, or in short KE. Before I go further, a little bit on the purpose of Kansei innovation. The aim is focused on enhancing consumers or users' satisfactions and people's happiness and quality of life. And there are 3 wins targeted to be achieved by KE, which are first, win for customers and workers, second, win for industry, and third, win for society. Kansei emphasize that these three things should come together, these 3 wins. Now, with that remark in mind, I would like to bring you to the field of KE. Kansei is a Japanese word which closely translated to mental state where cognition, sensation, and emotion and sentiment are harmonized. On the other hand, Kansei engineering is the technology for the development or improvement of products or services that embeds human emotional factors by translating the people's implicit feeling and demands into the design of products or services. Now, I'd like to show you examples of how human Kansei is influenced. For instance, when a lady enters a shop and then she sees a nice vase captivating her attention from one corner of the shop, she may immediately feel, I love it, in her heart. That is one. Secondly, perhaps you want to purchase a new car. So what do? Usually you would go from one dealer to another to browse for a car before making decisions. Imagine, for instance, the dealer you went to offered a bit more expensive price, but served with friendly gestures, with a smile and give good explanation in and out about the car and the purchasing process. And that results to the feeling of comfortable and confident to you, wouldn't it? Another dealer who is not friendly at all, treat you as if you're not worth for the car and didn't or couldn't explain much about the car you intend to purchase. Which one would a wise customer choose to buy from? A wise customer would go for the earlier one over the other dealer because they give good service, which resulted good feeling. That would also give a good indication that they would give you a better after-sales service as compared to the latter one. That's 2. Okay. And this third example is a real-life example of a failed electric cooker, which gives too many instructions, which ultimately made the housewife felt angry because it made them feel some kind of stupid. The product was soon failed in the market because it evoked negative feelings, although it was designed, firstly, for good functionality. All these 3 are examples of how characteristics of a product or surroundings cause different types of Kansei in users. Now imagine the scenario when you go into a new unfamiliar restaurant. Your kansei will take place even without you realizing it. Your vision, your smell, taste, and cognition would judge whether the restaurant is relaxing or very friendly or lovely or whatnot. This is kansei. And it goes something like this. When the view outside the large glass windows or walls, with that you may feel relaxing. Then with the service given by the waiter or the cook that come to you, you may feel that you are in a friendly and respectful environment. And then with the good taste of the food, you may finally conclude that this is a great restaurant and you will definitely come again and you will recommend to your friends. That concludes your kansei of the restaurant. You see, it all revolves around user experience. So what that shows is that kansei is a psychological feelings and images that people have with products and surroundings. It is a mental function which develops a higher function of the brain. This process of kansei begins with gathering sensory related functions such as feelings, emotions, and intuitions by means of the 5 senses that are vision, hearing, smell, taste, skin sensation, and it may add up with the 6th sense, which some of us may have. And when these senses are triggered, kansei will surface. So kansei, as being at higher function of the brain, it is implicit. Okay. As being implicit, kansei process cannot be measured directly. What can be observed are actually not kansei, but the causes and the consequences or effects of the kansei process. Therefore, kansei can be measured only indirectly by measuring sense activities via psychophysiological and behavioral responses. And those responses then express into kansei words, such as luxury, elegant, flashy, young, and so on. So how kansei is engineered? The philosophy is, if we can understand the product design characteristics, and then if we understand how people would respond to the design of the product, and then which is translated into kansei words, we can then find the interrelationships between these 2 factors. And with that intelligence, we can then formulate new innovative design of a product. This product is predicted to win the people's heart and mind because the product will be designed based on the people's emotional responses themselves. Now I'm going to show you some example of successful KE implementation. KE as in kansei engineering. The emergence of digital camera was inspired by KE and UX. It evolved from the classic camcorder to rotating handycam, to view cam, and to the recent digital camera, which then embedded into our mobile phones that we have now. Another very popular example of successful KE invention is a British sports car type called Mazda Miata, or MX-5, or Roadster as it is called in different regions. The car was designed almost 100% by KE, with only the tires excluded. The success of this car is recorded in the Guinness World Book of Records in 2000 as the most successful car ever in its class. And no car has taken its place until today. Another example of kansei UX with the element of easy to use in washing machines. The designers discovered the knowledge that slanted design, is slanting here, is most ergonomic as compared to the front or top door washing machine. And from the control panel, rounded arrows were added in the menu illustration to intuitively suggest the users to rotate the control knob. The colored line on the start button is designed so that it is easily discriminated than the rest of the buttons. Then Kansei in VR is nothing new. Panasonic has introduced a VR Kansei kitchen design system way since 1995. It is designed based on consumers' Kansei, where before clients decided for a specific design for a kitchen cabinet, they could select design parameters and experience the built cabinet based on the parameters using VR technology. With this, customers' Kansei, that is emotional UX, is catered for. This is an example of Kansei and web user interface design with the Kansei element of bright. It shows how the same contents, all these have the same contents and different layouts induce different emotional UX. Evidently in this, it shows that layout A and B are brighter than G, E, and F. Another example of Kansei UX in website user interface design, with the emotional elements such as feminine, cute, strong, comfortable, and etc., and the associated elements that significantly influence the user's emotions were put into a periodic table of website user interface design, borrowing from the chemistry field. Designers can click on the emotional design concept on the top menu, and then the associated design elements will be displayed for the designers to use as design inspiration to the design of intended website user interface design. This is an example of Kansei, an expert system for clothing design to allow users to make selection of design concept that they want to have, such as elegant, fun, futuristic design, and many more. And then choose age group, and then occasion, such as birthday party, corporate dinner, etc. And then finally, silhouette, whether A-line, bell, hipster, or hourglass, or others, based on what they imagine wearing. The system then recommends a few designs for them to choose from after they click submit button. The system inference was developed based on 100 Kansei concepts, 567 clothing designs, and these are also basis to the form of a Kansei database system, an intelligence system for clothing, fashion clothing based on Kansei. Okay, now we look at Kansei and AI and robot. Why do we talk about this? Is there any problem in AI robots? Okay, among the remarks was by Japan's KIS lab saying robot intelligence is still too mechanical or simplistic. Another remark, if robot wants to work with people, they need to be a bit more human. So to be more human, it must embed some sort of emotion in its design. This emotion is an important element humans are born with. Emotion is what makes us human. With conventional robot, among what had happened was users quickly tire of interacting with the robot. Users feel little sympathy for the robot whose actions are simple or routine and uncomplicated. Something for us to ponder, what is the difference between pets and pet robots? Well, the earlier is more responsive and invoke emotional attachment than the latter. The latter, just a static thing. So KE can play important role in solving this gap. So Kansei Robotics emerged to develop robots that generate emotion in the same way as living creatures by giving the robot functions that allow emotions to develop gradually, as in the process of human growth. How? For instance, by having humanoid robots that walk on two legs, a guidance robot that look just like human beings, such as one that acts as receptionist in Japan's department store, or pet robots that act like their animal counterparts, which walks, barks, wags its tail, and plays with a ball while never requiring owners to clean up after it. These robot called Aibo as the abbreviation, and at the same time matches the meaning that is companion in Japanese. And there's also Paro, a therapeutic robot. About Paro, the robot reduces patient stress with the caregivers and stimulates interaction between patients and caregivers. This causes a psychological effect on patients, improving their relaxation and motivation. It stimulates and improves the socialization of patients with each other and with caregivers. And this Paro robot is registered as the world's most therapeutic robot, certified by Guinness World Book of Records. There was a research on effort to design Kansei spiritual therapeutic robot for elderly with early stage Alzheimer. These people with this early stage Alzheimer usually feel shy and depressed because they cannot recall simple prayers parents to us. So considering these feelings, the research was done to embed those reminding roles into robots as mediating therapeutic agent. Okay, with regards to KE per se, from its inception, many industries have successfully applied KE and gained success in the market because the products they invented or innovated wins the hearts and minds of the consumers. Consumer products, household, automobile, as well as industrial products from Nestle, Matsushita, Shiseido, Toyota, Volkswagen, Boeing, and many more has proven its success in their product lines by the use of KE. Now we have come to the end of my presentation. I would like to share this. These are my books on KE that I have published. And if you want to have it to learn more on KE, you can get it online from the link on my website. 7 of them are in English. In one book, this book, Pengenalan Rekayasa Kansei, is in Bahasa Melayu. All right, that's about all I can share in this limited time. You can contact me at the email address listed, view my YouTube channel, or go to my website if you're interested to know more about my research work. Perhaps we can have research collaboration soon in the future. With that again, I thank you for listening, and I pass back the microphone to the moderator.
Thank you very much, Professor Anitawati. What a great quote you said earlier. Technology is best when it makes people happy.
Yes.
We will come back to you later for question and answer. So let's hear the second keynote speaker. And a kind reminder for all participants who want to ask something, you can write down your question on the chat feature. Okay. Our next keynote speaker is Dr. Hendro Cahyono. He is an expert in nuclear reactor safety and energy conversion. Graduated in electrical engineering from Bandung Institute of Technology in 1983. He had his master's degree in energetic physics from Institut National Polytechnique de Grenoble in France, 1987, and had his doctoral degree in energy conversion engineering from the same institute in 1991. Apart from this formal education, he also attended both local and overseas additional education and training to further improve his expertise in this field. He attended and became a speaker in national and international forums. With his expertise, he occupied some important and strategic positions and became a consultant throughout his career since 1980s. He is a member of Indonesian Professional Engineers Association since 1996 and Indonesian Researcher Union, Impenindo, since 2017, with a lot of high quality research and publications. So let's welcome Dr. Hendro Cahyono. Dr. Cahyono, please, time is yours.
Thank you very much. for the time. Okay. Yeah, I will try to present it. Thank you. My presentation title is the development of nuclear power plant technology in the world. Which technology is suitable for Indonesia? Yeah. So the content is my nuclear reaction, about nuclear reactor, type of current nuclear power plant, and generation of nuclear power plant technologies, development of small modular reactor, which technology is suitable for Indonesia, and the last is possible cooperation between UNIMED and Batan, as asked by Mr. Astel. So, ladies and gentlemen, concerning the nuclear reaction, what is the definition? What is the nuclear reaction? A nuclear reaction is a change that affects the nucleus of an atom. The four main nuclear reaction types are fission, fusion, nuclear decay, and transmutation. So, please we talk briefly what is the nuclear fission. Yeah? The nuclear reaction in which a large unstable nucleus break into two smaller nuclei. Nuclei is called nuclear fission. Yeah? Nuclear fission also release neutrons and a large amount of energy. Like alpha decay and beta decay, fission change the nucleus of the atom, take breaks apart. So like this, neutron strike the uranium atom, and uranium atom fission and breaks to two atom, yeah, like krypton, barium, and other possibility also, yeah, and also emit also two and until three neutron, 2 or 3 neutron, yeah, the new neutron. So, how about nuclear fusion? Nuclear fusion is the process by which nuclei of small atoms combine to form a new, more massive nucleus. Fusion reaction changes a small amount of mass into a large amount of energy. So the very light atom like hydrogen and tritium, yeah, combine and produce amount of energy, yeah, and also produce the beta particle like this, and other particle also. How about nuclear decay? Nuclear decay is the process by which an unstable isotope of particular elements spontaneously transform into a new element by emission of ionizing radiation. Unstable nuclei continue to decay until they form stable nuclei. Three kinds of radioactive decay are alpha decay, beta decay, and gamma decay. An alpha particle consists of 2 protons and 2 neutrons. It is the same as a helium nucleus. Beta decay is the release of a beta particle and energy. There are 2 types of beta particle, positron and electron. Both particles have a mass of almost 0. Positron have a charge of 1 plus, electron have a charge of 1 minus. Gamma rays are released during gamma decay. Gamma rays are a high energy radiation and have no mass and no charge. So nuclear decay, so very number possibility. That is an example for uranium 238 with decay by emitting alpha to be thorium 234, iodine 231, and decay by emitting beta to xenon 231. Thorium decay by emitting gamma, positron, carbon emitting positron decay to boron, and etc. So many kind possibility. And this fourth nuclear reaction is transmutation. Transmutation is essentially the reverse of nuclear decay. It is a non-spontaneous process whereby one element is converted to another by the bombarding it with high energy radiation. It can be neutron, helium, protons. This is generally an artificial process that allows the creation of radioactive isotopes. For example, palladium-103 that is used in the treatment of prostate cancer is made in laboratory, is made by bombarding palladium-102 with high energy neutrons. Transmutation involves increasing the mass of nuclei. We talk about nuclear reactor now. What is nuclear reactor? It is a device where the nuclear reaction takes place. The type of nuclear reaction in the actual reactor are the fission and the nuclear decay in actual reactor. Fusion is not yet, not yet. A nuclear reactor, any of a class of device that can initiate and control a self-sustaining series of nuclear fissions. Nuclear reactors are used as research tool. We call a research reactor a system for producing radioactive isotopes, and most prominently as energy source for nuclear power plant. So, principle of operation of nuclear reactors. Nuclear reactor operate on the principle of nuclear fission, the process in which a heavy atomic nucleus split into two smaller fragments. The nuclear fragments are in very excited states and emit neutrons, other subatomic particles, and protons. The emitted neutron may then cause new fissions, which in turn yield more neutron, and so forth. Such a continuous self-sustaining series of fission constitute a fission chain reaction. We call chain reaction. A large amount of energy is released in this process, and this energy is the basis of nuclear power system. So there is a chain of fission. All the neutrons strike the nucleus and is absorbed. The absorbed neutron causes the nucleus to undergo deformation in about 10 to 14 seconds. One of the deformation is so drastic, and this nucleus cannot recover. So this releasing of a rate of 2 or 3 neutron, the nucleus fission, and also emitting the number of gamma ray. Now the fragment are called fission product. So in fission, it's produced gamma and also a neutron, the new neutron. what is difference between atomic bomb and nuclear reactors? So, in an atomic bomb, the chain reaction is designed to increase in intensity until mass of the material has fissioned. This increase is very rapid and produce the extremely prompt, tremendously energetic explosion characteristic of such bomb. So the fission chain is uncontrollable in atomic bomb. So a very rapid process. But in a nuclear reactor, the chain reaction is maintained at a controlled, nearly constant level. Nuclear reactors are so designed that they cannot explode like atomic bomb. Okay, so the big difference between atomic bomb and reactor. This is a chain reaction in nuclear reactor at a critical state, starting from, for example, a two slow reactor, slow neutron taking, and this one is produce three fast neutron, and pass through a moderator nuclei to be slowed, to be slowed, and slow again the slow neutron track again and continue that. So if in critical, or with what we call in critical condition, is the one generation of neutron, the number of one generation neutron produce also the same number of neutron also in the second generation, and the same produce also the same number of neutron in the third generation. So in a research reactor, about research reactor, this picture is a research reactor in Serpong in Indonesia, in our research reactor. There are in the world there are 252 research reactor in operation in 55 countries, including Indonesia, with 3 reactors in Serpong, Bandung, and Yogyakarta. Continue to play an important role in supporting medical, industrial, education, and nuclear power sector. So this image, this picture is a research reactor in. I take this picture from my office. This one, okay, because I work in this area. So this main component of a research reactor with the pool type of research reactor. This one is we call fuel element is here. We call the core of the reactor, and the very deep, about more than 10-meter silt of water, to see the gamma ray. So the basic component of nuclear reactor. There are large number of ways in which a nuclear reactor may be designed and constructed. Many types have been experimentally realized. Most reactors, however, have certain basic components. The basic component of a nuclear reactor is there is a fuel element, there is a moderator, there is a control rod, there is a radiation protection, a barrier. There is also a heat removal or a cooling, a coolant. This is a basic component of a nuclear reactor. So how about a nuclear power reactor? In nuclear power reactor, the energy released during a controlled chain fission reaction is used to generate electrical energy. Most nuclear electricity is generated using just two kinds of reactor, such as PWR and BWR, which were developed in the 60s and improved since 1960s. New designs are coming forward, and some are in operation as the first generation reactor come to the end of their operating lifetimes. About 10% of the world electricity is produced from nuclear energy. It's around 10% nuclear energy. So different cooling loop cycle of nuclear power plant. There are three kinds. One is a single loop, two loops cycle. A single loop cycle is like BWR. So it is a core or the fuel element here, and the coolant pass through fuel element and become steam, become steam, and to turn the turbine, to turn the turbine directly. So the second is two loop. So the steam to turn the turbine not directly pass through the element, the fuel element, in the second loop. It's like the PWR or can do also a pressurized heavy water reactor. It is two loop. There is also this third or three loops. This is found only in a sodium cooled reactor. With intermediate, there is intermediate loop of non-radioactive sodium is here. Okay. What we call the nuclear power plant, usually we talk about the power rating. There are three kinds, three names of power rating: thermal, thermal power, in megawatt thermal, which depend on the design of the actual nuclear reactor itself, and related to the quantity and quality of the steam it produce. And second is gross electrical megawatt electric, and the third is net electrical megawatt electric. So gross which indicate the power produced by a steam turbine and generator, and also take into account the ambient temperature for the condenser circuit. And net is which is the power available to be sent out from the plant to the grid, after deducting the electric power. So the status in right now is a nuclear power plant in operation right now. In the total is number is around 441 number, with a total power of 390 gigawatt. There's only six type of pressurized water reactor. The majority is around 2/3 part or 68% is PWR. A boiling water reactor is around 15%. A pressurized heavy water reactor 10%, and gas-cooled reactor, light water graphite reactor, and fast neutron reactor. Those So this kind of nuclear power plant and is in operation right now. The primary coolant, the coolant for there is different coolant, water, heavy water, CO2, carbon dioxide, yeah, helium, sodium, liquid bismuth, fluoride, salt, yeah. It is used as coolant of nuclear power plant. So with the temperature is very, yeah, very. This is the PWR is around 300, yeah, degree, and also there are also the very high temperature, maybe in 900 and 1000 degree, yeah, is at the air. This is the next generation of reactor. So the composition type of reactor. So I must rapidly. This is a pressurized water reactor. Yeah. The scheme is like this: pressurized water reactor, two loop, yeah, with two loop, the one loop and second loop here, yeah, one loop and second loop. The pressure is very high. Yeah, the pressurized water reactor. The pressure is around 150 bar. Yeah, 150 bar. Yeah. This is to maintain the condition, not boiling condition, so to avoid the boiling, yeah, with high temperature, around 100 temperature. So I pass rapidly with the time. So it passes this, the fission energy is take and cooling by the water, and the energy is transferred to the steam, yeah, to produce a steam in a secondary side. Yeah. The steam produce the turbine, yeah, turn to a turbine and generate electricity in the generator, yeah, by the generator and continue. Yeah. So what we got net megawatt is in this, yeah. Gross megawatt is the output of the generator, and thermal megawatt is the output of the steam, yeah, into it. This is a PWR core, yeah, PWR core with this full element like this. Its full element is around with 200 and 300 rods, road effectively. There are about 150 full assembly like this, yeah, in a big large reactor, yeah, 150 assembly like this, with a total of around 80 tons of uranium. Yeah. So the second is a boiling water reactor. You can see the difference with PWR. The steam is produced directly in the reactor, yeah, directly in the reactors. So just one loop only, yeah, direct difference. And the difference also in the control rod is from the under, yeah, under the core, yeah, yeah, because it is above the core is very busy, too much many components. That's So like this, so many components in a bus. That's why the control rod is just inserted from the under, yeah, what the below the core, yeah. So I pass this same and heavy water reactor PSWR, yeah, reactor is function like PWR. The difference is just in the reactor or the core. Reactor core is the difference. The other is the same. Okay. Pass. There is also an advanced gas reactor. Yeah. Okay. I skip. Yeah. I skip this because it's time. Yeah. The fast breeder reactor. Fast breeder reactor is not too much, only 2 or 3 now, yeah, in operation now. Today. We categorize the technology of nuclear power plant in by generation. So there is generation 1, 2, 3, 4. Yeah, it's a generation of nuclear power plant. Yeah? But generation 1, generation 2. Yeah, generation 2 is PWR, BWR, can do. Yeah, PWR. There is also generation 3. Yeah, can do 6. Yeah? And generation 3 plus. Yeah. APVR, AP600, and etc. And also generation 4 is generation 4 is not yet, maybe in one in 20 years, maybe in generation 4, yeah, 2030, 2014, yeah. Generation 1 consists of early prototype reactor, yeah, from the 15 and 16. No generation 1 reactor still in operation actually. Generation 2 refer to a class of commercial reactor designed to be economical and reliable. So reactor in operation now is majority is generation 2, yeah, Gen 2, majority of. Gen 3 is the nuclear number, essentially Gen 2 reactor with evolutionary state-of-the-art design improvement in the area of fuel technology, thermal efficiency, modularization construction, safety, etc. Yeah. And also there is also 3 plus, a significant improvement in safety. Yeah. So many kinds. So this is the 3 and 3 plus nuclear power plant. Only one is in operation now, another is still under construction. There's also under construction. It's with red colors. Gen 4 is still in study. Yeah? Gen 4. The 6 nuclear reactor technology for deployment between 2020 and 2013. Yeah. So a 6 represent advance in sustainability, economy, safety, reliability, and proliferation advance resistance. So this is a 6 design of Gen 4 reactor. Yeah. Still in design, yeah, still in design. And also the development now the small modular, they do partly of the high capital cost of large power reactor generating electricity via steam cycle and partly to the need to service small electricity grid under about. There is a move to develop smaller unit equal less than 300 megawatt. Actually, there are 5 small reactors operating, 3 small reactor technology under construction, 12 small reactor technology for near-term deployment, 23 at earlier stage, and 9 very small reactor technology being developed. So more than 25, yeah, small reactor is already designed. Yeah. So many, okay, and I just so many kinds. This is a 125 here. There is also water cooled, gas cooled, liquid metal cooled. Yeah. There's also current, smart, SCP, NuScale, etc. There are all a small reactor. The power under 300 megawatt. So I just skip this just for information to you. Just see the small reactor is usually as a compact design, yes, a compact design, and very it's to modify for example, many in the last PWR we can compact it to this in small reactor. Pressurizer inside this, pressurizer, steam generator also inside this. So all this one is can to see. Okay?
Yeah, a kind reminder, please, for the time. Thank you.
Continue related to this. How about in Indonesia? Yeah. Okay. In Indonesia, basically, all technology could be implemented. Yeah. In Indonesia, depending on location and with this new technology, with the priority of at least Gen 3 technology. For Java and Sumatra Island, which have the big size of electrical grid, it is preferable to implement the last reactor technology. For other islands with smaller grid size, the small module reactor is more suitable to be implemented. In principle, all technology proposed to be implemented in Indonesia must comply with all national regulations. So, conclusion. The nuclear reactor technology in the world has developed rapidly with offering significant improvement in safety and economic aspect. Very large number of SMR type give the big choice in implementing a nuclear power plant in Indonesia. Depending on location and the readiness of technology, basically all nuclear power plant technology of at least Gen 3 are suitable for Indonesia. The use of SMR is preferable for the small electrical grid, and the large NPP size is for the big electrical grid like in Java and Sumatra. In principle, all technology proposed to be implemented in Indonesia must comply with all national regulations. So, the last presentation is on possible cooperation between UNIMED and Batam. Maybe a joint research on reactor safety simulation using code and experiment. We have some laboratory to this, and practical works tugas akhir, what we call the final task or thesis for student, undergraduate or graduate program. Cooperation in publishing paper for national or international journal. Okay. Sorry, and thank you very much for your attention. Sorry for the time. Thank you very much.
Thank you very much, Dr. Cahyono, for your presentations. It's a relatively simple but clear way. So even for me, a common person related to nuclear power, I can understand a bit about it. Thank you very much, Doctor. Okay, Professor Anita and Dr. Cahyono, we have some questions at this moment. Let me see. The first one for Professor Anita from Mr. Abu Bakar. How can an emotional element be added to the learning design? For example, stimulating feelings of happiness in doing tests in an application. Thank you. Could you please respond for this question, Professor Anita?
Yeah, if I got the question correct, the question wants to know how we can actually embed emotion into the product design. Is that the question?
Yes, I think so.
Okay. There is a methodology, a few different methods in concept engineering that we can follow to actually embed emotion into product design. First, what that we have to do is to assess the emotional responses of consumers towards the product that you want to innovate. If it is you want to innovate from existing product. Okay, there's also another way of creating product from scratch. It's another method, which is a qualitative method. To explain in simple, I explain one simple method in quantitative assessment. Is that we can actually identify first what are the keywords that represents the emotional responses of consumers to the products. For instance, handphone. You put a few handphones and you try to get the knowledge of how people respond to the product by asking, observing, and many other ways. And then you use that knowledge to create an assessment, like a self-evaluation checklist from 1 to 5, using SD scale from 1 to 5 or 1 to 7 or other 1 to 11 whatsoever, but the recommended one is 1 to 5. So you assess the emotional responses by using around 30 to 50 respondents, so that you can confirm the emotional responses that consumers have with that product. That is one aspect. The other aspect is that you have to assess the design characteristic that exists at that product. Okay, whether the color is green or red or blue, the shape is rounded or sharp or what, and then other aspect of characteristics, design characteristics, and then you use the first knowledge to actually assess against the second, which is the product, to actually assess the subjective feeling that consumers have towards that product. And then we do some kind of statistical analysis to actually associate that response with the design characteristics. So with that, we can know the most influential emotion and then what affects that emotion, the design characteristics that affect that emotion. So that in the future, you use this knowledge to create a new product that match this emotion. If you get that. I need to give you a course.
Okay.
Be able to do it.
Yeah, thank you very much. That's a clear answer, I think, that we may consider in any field of expertise, also in learning design problem as asked by Mr. Abu Bakar. Thank you, Professor Anita. The second question also for Professor Anita is there from Mr. Pikiran Surbakti. Is there any relationship between emotional design with the neuron in human head or body?
That question for me?
Yes.
Okay. Emotion and neuron design in human body?
Yes.
You're talking about metaphysics or something?
Maybe.
Oh, okay. Actually, I got that similar question before, but okay. Let's put it like this. If you can translate that neuron in human body or whatsoever, or the metaphysics, into something that we can tangibly assess, then we can. Because no matter how, to by observation perhaps, and then you translate about the characteristic of the perhaps how people behave, for instance, then we can.
Okay. So still there is a way to assess the connection between those.
Yes.
Okay. Another question for you, Professor.
Okay.
It seems that a lot of people are interested to
Challenging
your
questions.
presentation. It's from Miss Nur Fajriani. How aesthetic and customer factor are very essential in emotional design.
Oh, of course, it is very essential, very much important, because we have to understand the consumer's emotion, and then relate that to the looks, or you may call it aesthetic whatsoever, or the design characteristics of the product. And then only it actually in the future, if we can design the product that embeds this emotion, we can have a product that can predict that the consumers will have that emotion when looking at that product in the future. So it's very important.
Okay. So it means that there's a predictive feature in this way.
Yeah, it's kind of prediction of what people would feel when we produce that product, such as when we first see a new handphone design, so when you see this kind of design, when it was first introduced, before that it wasn't in the market, people will be captivated with the design because of the maybe large screen, and then whatever the color or whatsoever. Because it was predicted by the design. If people look at it, people will be attached to it and will be captivated and will be influenced to buy. That is the concept of Japanese manufacturing companies for long, when they came out from the the era of the dark era of the Hiroshima bombing and all, and then not even taking 10 years to become the world power in economy at that time, because they created or innovated product that can actually predict humans' emotion, because when they look at it, they will have emotional attachment to it.
Okay. The last one for you, Professor Anita.
Okay.
What we have to do in order to always feel happy, satisfied, and enjoy, although there are many things around us that make us unhappy.
Okay, that is actually a different discipline. But what Kansai engineering does is to actually create a product or services that can make people happy in general. So when they are happy, they consume, they buy, they believe in that service and whatnot. But this question, I think, is more to positivity of ourselves, and to have that positivity, to have that positivity, there's also a lot of characteristics, and we can make that characteristic meet our emotion that makes us feel positive. Then you can actually engineer all your surroundings, maybe your family, what you have, around you, to have that characteristics that make you feel happy. Something related but different discipline, but can relate.
Okay, thank you, Professor Anita. We will come back to you later. We have some question for Professor Cahyono here.
All right.
Dr. Cahyono, there is a question here. What software that you use to control all of reactor instrument in your laboratory? May we access and use the software freely?
Okay. In our laboratory, usually, our center is usually have some laboratory just for studying the safety of nuclear power plant. Yeah? So in this laboratory, we don't have a real something like a nuclear power plant to be controlled, but we develop also what we call the a simulator of nuclear power plant, And with the simulator V study and the combination of the other the case the accident case, etc. We study with this. Yeah. In this development, we develop ourselves the software, the program, using also the existing program to calculate the phenomena, the thermal hydraulic phenomena in the nuclear reactor, things like relay, Cobra, etc. And also we combine with neutronic program, to combine the thermohydraulic and neutronic in this case. So in my center, we don't have laboratory and real physical, but we have the simulator, simulator in for the control of nuclear power plant, like this. We have many hardware laboratory for studying the phenomena, the accident phenomena in thermal hydraulic aspect, especially in cooling aspect of reactor. Yeah. That's fine.
Okay, thank you, Pak. Another question, Pak. What is the biggest problem in developing reactor to produce electricity, and how to solve this problem to ensure our government that building reactor nuclear is safe and become solution to address energy problem in our country?
Yeah, this is the difficult, difficult question. So like this, the situation is like this now. In the in point view of economical safety, etc., and also the feasibility study or the public acceptance is no problem now. Yeah, public acceptance is around 80% is okay with a nuclear power plant. Yeah, and also in point view of economic also is no problem. Yeah. There are many countries also can introduce or build a nuclear power plant even without money for our part. So, but we still waiting for the president, because for the building a nuclear power plant, the president must the decision is in the hand of president. So we still waiting, Mr. Jokowi, for this. No problem about the parliament. Parliament is okay now. The ministry is okay, no problem. But still, one person is president of Indonesia, Republic Indonesia. This one.
Okay. So do you mean that we are actually ready for the technology and for the risk that may come from this technology?
Yeah. Yes, if it becomes solution. Yeah.
Okay.
For the technology is no problem. Yeah. And also for the main hours, it's okay. Right now, we operate 3 reactors. Until now, it's no problem. 3 reactor research reactor in Indonesia. Until now, it's okay. So so we are waiting all the decision only for this president.
It's about the policy now.
Yeah.
Okay.
The policy.
Thank you, Pak.
The big, yeah, thank you.
I would like to invite all the participants who still want to ask some question or further questions from before to raise your hand or to say something from your place, please. While waiting, I want to ask of Anita. Some people choose a far more expensive gadget rather than a cheaper and relatively good one with all features that the person needs. So why do these people choose the more expensive one rather the cheaper one? What happened here? Please, Professor.
Good question. You see, as I gave example just now about iPhone, you know,
Yes.
it's expensive, but some segment, market segment, they choose to buy that brand because of its a statement of status, perhaps. You know, there are still some people like that. But then I see the trend today that most of us, most of the people, the consumers, we go for cheaper products so that we can change faster.
Okay.
Right? So actually the trend is changing, but there are still hardcore people that go for those, you know, if you can get like a equally good quality product, you know, why don't we go for the cheaper one? Because the design is better. So it's a battle between the manufacturers actually, and that's why for instance Huawei is making, you know, taking over some of the market segments because they are cheaper but they offer a lot of better functionality as compared to iPhone. And that's the industry battle. So but there are still supporters, you know, those that you don't want to have, you don't want to say that statement that I am iPhone fraternities, for instance. Yes, they go for that. Like people go for BMW cars instead of what in Indonesia, Kijang.
Kijang, yes.
It brings us to the same destination if you use it. But why people go for BMW?
Sure.
It's just they are happy with that. So that is why also manufacturer is still there for that kind of product because there are still demand. So the market are different. So for manufacturers or producers, it depends on them to which segment they want to actually penetrate. Of course, iPhone because not many people buy. That's why they set high.
Okay, so it's kind of different satisfaction factor for each people.
Betul.
Okay, thank you, Professor. Is there any question still, please? Okay, I think we can still contact our keynote speaker if we have further questions through their emails. So I encourage you to contact our keynote speaker. Thank you for this fruitful session, our distinguished keynote speakers and all participants for your participation. Now I'll return to the moderator, please. Thank you, Bu Cecilia.
Thank you, Mr. Mahatua.
Terima kasih Pak Cahyono, terima kasih Prof. Anita.
Terima kasih.
Well, thank you, Bapak Simanjorang. Ladies and gentlemen, before going to the parallel session, we would like to invite you to have a break. Then we'll proceed again to this room at 1 p.m. and the parallel session will be taken over by the moderators for every room. We also would like to inform the keynote speakers that we allow you to participate in any room of parallel session. Ya, Bapak Ibu yang kami hormati, untuk sementara waktu ruangan konferensi ini akan kita tutup dan kita akan kembali lagi pada pukul 13 waktu Indonesia bagian Barat. Dan untuk sesi paralel akan diambil alih oleh para moderator. Kami juga mengundang para keynote speaker untuk bergabung di sesi paralel. One more important information for all of you who will participate in parallel session. There will be an announcement of the best video presenters for every room at 5 p.m. So it is hoped that all of you will be stay tuned on this conference room until the closing ceremony. Thank you.
Baik, terima kasih Bapak Ibu. Thank you so much for our keynote speaker, for distinguished keynote speakers, Professor Anita, Professor Hendro Cahyono, Professor Cakrapong, and also Professor Dr. Siri Parapa. Thank you for your attention and for coming to this conference. And also I invite all of you to enter to the parallel session at 1 p.m. o'clock. Terima kasih kepada Bapak Ibu peserta dan juga presenter partisipan. Kami ingatkan kembali terkait dengan paper Bapak Ibu telah selesai direview oleh reviewer. Mohon bisa mengecek komentar daripada para reviewer untuk perbaikan ataupun untuk revisi Bapak Ibu, paper Bapak Ibu. Adapun nanti revisi paper akan diterima oleh panitia paling lambat tanggal 10 November tahun 2020. Jadi bulan ini tanggal 10 November kami harapkan Bapak Ibu sudah mensubmit kembali paper yang telah direvisi sesuai dengan komentar para reviewer. Tanggal ini sangat penting Bapak Ibu, mohon tidak lewat tanggal 10 November, karena di pertengahan November, ataupun paling tidak di akhir November, panitia akan mengirimkan ke publisher untuk direview ulang ataupun dicek kembali. Kita harapkan nanti di Desember, paper tersebut sudah dapat diterbitkan oleh Journal of Physics Conference Series. Demikian Bapak Ibu pengumuman terkait dengan paper-paper tersebut. Adapun nanti hal-hal yang berkembang ataupun yang mungkin Bapak Ibu bisa tanyakan bisa melalui grup WhatsApp kita. Jadi kita akan kembali Bapak Ibu pukul 13.00 atau pukul 1 siang sesaat setelah kita istirahat, sholat, dan makan. Terima kasih Bapak Ibu, selamat siang semuanya.
pancur sisa melamering mo bagai turang ale mardida kalakmo bekel masada duan dando ale kapitapo duan dando ale kapitapo. manikam di varjoget soro manigotam bina mangingani si bambang kartula tula si bambang kartula tula sik sila manikam di varjoget soro manigotam bina mangingani si bambang kartula tula si bambang kartula tula soro manigotam bina mangingani si bambang kartula tula si bambang kartula tula si bambang kartula tula ampar pisang pisangku belum masak masak sabigi di hurung bari-bari 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 Cucuk gempelengan nunggi wakuku gempelengan bakul lempang sekan meda di salatan bakul lempang sekan meda di salatan Lagu ini dengan sangat bangga saya persembahkan khusus buat teman-teman saya dari Sabang sampai Merauke. Saya Anmes Kamaleng, dari hati dan semangat yang paling membara. Satukan tekad, padukan bangga, dirgahayu Indonesiaku yang ke-73, kerja kita, prestasi bangsa.
bandinganana dipika gimil dipika serapku sasama taya karempan kasian leber wawanena manu dadali manu panggagana perlambang sakti Indonesia Jaya manu dadali pangka koncarana resepna hiji rukun sakabena
hidup sauyunan tara bahiri-hiri silipikannya tu ingis belapati manu dadalingan bung silo kasinatria Bursakumna bangsa di negara Indonesia
luhur jauh di awang-awang meberkenjang-jang na bangun taya karingrang suku narang goas rejeng pamatuk nangelu ngepak meka bari bernatarik nyuru
saha anu bisa nyusurkan tandangna kandang jung pertentang taya bandinganana dipika gimir dipika serapku sasama taya karempan kasihan leber wawanina
manu dadali manu panggakana perlambang sakti Indonesia Jaya manu dadali pangka koncarana resepna hiji rukun sakabena
hidup sauyunan tara bahiri-hiri silipikannya tu ingis belapati
manu dadali ngandung silo kasinatria kursakumna bangsa di negara Indonesia
Kan udah dikasih sih videonya sama si Andre. Dari sini masih ada di sama dia di auditorium. Jangan bilang gitu lah.
Come up to meet you, tell you I'm sorry. You don't know how lovely you are. I had to find you, tell you I need you, tell you I'll set you apart. Tell me your secrets and ask me your questions. Now let's go back Nobody said it was easy. It's such a shame for us to part. Nobody said it was easy. No one ever said it would be this hard. Oh, take me back to the start. I was just guessing at numbers and figures, pulling the puzzles apart. Questions of science, science and progress did not speak as loud as my heart. Tell me you love me, come back and haunt me. Oh, when I rush to the start, running in circles, chasing tails, coming back as we are. Nobody said it was easy. Oh, it's such a shame for us to part. Nobody said it was easy. No one ever said it would be so hard. I'm going back to the start.
Here's some new escape music for you.
Just a small town girl living in a lonely world. She took the midnight train going anywhere. Just a city boy, born and raised in South Detroit. He
took the midnight train going anywhere. A singer in a smoky room, the smell of wine and cheap perfume. For a smile they can share the night. It goes on and on and on and on. Strangers waiting up and down the boulevard. Their shadows searching in the night. Street lights, people living just to find emotion.
Bantahi Prodi. Udah moodnya tuh. Di luar. Sorot kita.
Minum 10 nih. Udah namanya. 10.
Tahu sudah itu.
Bagi perlu.
Belum kan?
Aku nggak login, lah apa login?
Apa login? Sepakat terus malam itu nggak perlu login apa? Dikawanin aja. Oh.
Aku lagi promo itu tuh. Dulu cuman satu ceritanya.
Tinggal sekali mungkin di sana. Semua poster mau apa tetap halo tabrakan enggak mbak enggak itu tanya tabrakan sakit Gimana mau dulu?
Ya barangnya.
Kan mau dibuat tulisannya rupanya.
Oh, buat aja di sini. Itu nanti diumumin.
Diumumin aja lah.
Aku umumin nanti aku umumin nanti Kak di akhir.
Bisa ditulis. Gini.
Oh, ditulis. Iya. Itu di mana mau di sini gitu? Oh, untuk ininya, untuk waktu ngumumin gitu ya? Well, ladies and gentlemen, now we come to the parallel session of this conference. Seluruh peserta diminta untuk ya bisa berjoin ke ruang paralel. Ya, kami minta seluruh peserta untuk segera join di ruang paralel dan jangan lupa untuk mengklik join apabila klik tombol join masih dalam posisi belum terklik. Kami juga memohon kepada partisipan yang belum merubah username, silahkan rename your username. Ya, seperti yang dikemukakan sebelumnya, username yang peserta bisa gunakan adalah, for example, contohnya rxx underscore and then username, your name. Sebagai contoh R01 underscore Sisila Damanik. Ya, seperti itu. Pak Wahyu Triatmojo, mohon informasikan Bapak ada di ruang berapa, Pak? Ya, Pak Wahyu Triatmojo, mohon informasikan kepada kami Bapak berada di room berapa? Ya, Ibu Neti Juliana, juga mohon diinformasikan.
Saya di
yang peserta pertama sih.
Halo.
Bu Ida diganti namanya.
Bu.
Pada Ibu Ida juga kami mohon untuk rename your username seperti yang kami kemukakan di awal tadi bahwasanya peserta diminta untuk rename the username dengan pola rxx underscore kemudian tuliskan nama. Ya, Pak Wahyu, kami mohon untuk juga mengganti.
Di mana gantinya?
Tidak dalam posisi yang atau tidak dalam bentuk yang sama. Contohnya R01 underscore nama.
Oke. Siap.
Coba diperagakan penggantian nama itu, sepertinya ada beberapa kesulitan tuh.
Baik Bapak, sekali lagi kami informasikan untuk penggantian nama dengan pola R nomor ruangan.
Caranya Bu, caranya.
Caranya Bapak.
Ya, silakan Ketua.
Harus mengklik partisipan.
Iya, kemana?
Ya, yang ada di posisi sebelah kanan, di bawah, di samping share screen.
Enggak, gini aja.
Di samping share screen ada posisi partisipan. Silakan klik.
Saya bantu itu ya. Saya bantu jelaskan dulu.
Ya, Pak Asep, persilakan untuk membantu menjelaskan mengganti atau rename username.
Bu Sila.
Baik.
Bu Sila.
Sila.
Ya.
Pak Wahyu udah berhasil. Bu Duma tinggal klik kanan di nama Ibu, klik kanan pakai mouse-nya, kursornya itu diklik kanan di nama Ibu Ida Dumaririsnya, terus ada nanti muncul rename. Tinggal pilih rename-nya saja Ibu, klik kanan di nama Ibu, pakai mouse, kemudian nanti ada pilihannya rename. Rename itu klik baru ganti R berapa Ibu, di room berapa. Ibu di ruang berapa, tinggal isi R, misalnya kalau di ruang 8, R08 gitu. Silahkan Bu.
Saya ruang 4.
Segera mengganti.
Baik, kita akan bantu Ibu Duma. Kita akan bantu sendiri ya Bu.
Ya.
Sudah.
Yuk.
Oke, Ibu silakan nanti
Makasih.
ke ruang 4 ya Bu. Akan dipindahkan host.
Silakan hostnya memindahkan.
Bapak belum menerima. Bapak meeting. Ibu.
Dah.
Meeting dulu. Meeting dulu.
Ya, selanjutnya Ibu. Kami mohon untuk rename username-nya, Bu. Ya, di R01, Ibu. Silahkan tuliskan namanya setelah underscore. Ya, Bapak Edo. Bapak Niel Ananto, ya Niel Ananto. Bapak Niel Ananto, kami melihat belum merename username-nya. Bu Bakar, tolong informasikan kepada kami, Bapak berada di room berapa? Bapak Abu Bakar.
Ya, halo Bu, selamat siang. Di room 7, Bu.
07 ya Pak, room 7. Oke, baik Bapak. Ya, Bapak Niel Ananto juga belum terlihat telah mengganti username-nya. Ya, Pak Niel Ananto berada di ruang berapa, Pak?
Sorry, room 5.
Ya, Pak Niel Ananto di room 5 ya.
Iya.
Baik, Bapak. Siapa belum klik join? Bapak Hari Mintarigan, kami mohon untuk mengklik breakout di bawah, karena di sini belum masuk ke.
Oke, ya Bu, sudah. Join.
Oke, join Pak, join. Room 4 Bapak ya. Ya, Bapak atau Ibu yang berada di room 10, ya, boleh diklik breakout room-nya Bapak atau Ibu yang di room 10. Ya, Bapak Martono. Pasca Marto. Pak Marto, silahkan klik breakout room-nya, Pak. Begitu juga dengan Ibu Susilawati. Ibu belum mengklik breakout room. Ya, silakan klik yang ada di bawah ya, Ibu. Begitu juga
klik breakout room baru join breakout room ya, Mbak.
ya, breakout room, Bu. Kemudian klik join. Ya, selanjutnya Ibu Hijriati juga belum mengklik breakout room-nya. Silakan Bu, diklik. Ya, kami kembali ke Bapak Edo Berlian. Bapak berada di room berapa, Bapak? Sekali lagi, Bapak Edo Berlian. Masih ada. Ya, sekali lagi kami ingatkan kepada Bapak Edo Berlian. Bapak berada di room berapa, Pak Edo Berlian? Begitu juga dengan Ibu Meliana, belum masuk ke ruangan ini Ibu. Ibu Meliana. Bapak Pasca, kenapa kembali lagi ini Bapak ke main room Bapak? Bapak Pasca, mungkin Bapak harus mengklik sekali lagi breakout room-nya Pak. Ya, Pak Pasca, silakan klik breakout room ya, Bapak. Breakout room, kemudian Bapak bisa mengklik join. Ya, selanjutnya Ibu Ayu Fitriani. Mohon diinformasikan Ibu berada di room berapa, Ibu? Ibu Ayu Fitriani. Bapak Marsub Sirait. Ya, mohon diinformasikan Bapak berada di room berapa? Ya, Bapak Bayu Negoro. Kami melihat Bapak juga belum masuk ke breakout room. Silahkan diklik Bapak breakout room-nya. Oh ya, konfirmasi Bapak berada di room berapa, Bapak Bayu Negoro?
Saya di room 3.
Oke, room 3 ya Bapak.
Ya.
Bapak ini sepertinya belum mengganti username dengan pola yang kami sebutkan di awal tadi. Ya, Ibu Ayu kami lihat juga belum masuk ke breakout room. Sekali lagi kami tanyakan Bapak Edo Berlian, kami belum melihat Bapak join to the break room. Silakan informasikan kepada kami. Bapak ada di ruang berapa, Pak? Pak Edo Berlian dan Bapak Eko Prasetyo. Bapak Edo Berlian dan Bapak Eko Prasetyo, silakan informasikan kepada kami Bapak berada di room berapa? Ya, selanjutnya Ibu Destrika, Ibu belum mengklik breakout room-nya, Bu. Silakan diklik breakout room, kemudian klik lagi join. Ya, Ibu Ayu belum mengganti nama ini, Ibu. Ayu Sriminda. Ibu Ayu Sriminda, silahkan rename dulu, Ibu, username-nya.
Ganti nama lu. Cuma ganti nama ya.
Baik, Bapak Edo Berlian, tolong informasikan kepada kami, Bapak berada di room berapa, Bapak?
Di 04, Bu.
04, baik Bapak.
Ya, ya.
Ya, Ibu Ayu. Ibu Ayu baru masuk kembali ini Ibu ke main room.
Iya, iya ya Bu.
Ya. Silakan ke breakout room ya Ibu Ayu.
Oke.
Ya, Bapak Jul Indra berikutnya. Kami belum melihat posisi Bapak berada di room berapa, Bapak? Bapak Zul Indra, tolong konfirmasi kepada kami di room berapa?
Room 5, Mbak.
Room 5, oke Bapak. Pak Zul Indra belum rename ya? Oke. Ya, selanjutnya Miss Yuni. Ya, mohon konfirmasi, Ibu berada di room berapa? Ibu Ayu Sriminda ini belum masuk ya ke break room. Ibu Ayu tolong konfirmasi Ibu berada di room berapa Ibu?
Saya room 02.
02, baik Ibu. Ya, Miss Yuni. Tolong konfirmasi kepada kami berada di room berapa, Ibu? Selanjutnya Ibu Asmaul Husna. Belum terlihat roomnya ya. Oke, Bu Asmaul Husna belum terlihat roomnya ya, Ibu. Tolong konfirmasi kepada kami di room berapa, Ibu? Ibu Asmaul Husna, tolong konfirmasikan Ibu berada di room berapa? Masih ada? Ya, Miss Yuni tadi, Ibu Miss Yuni.
Iya, saya berada di room 10.
Di ruang 10. Ibu Miss Yuni ya?
Iya, Ibu.
Oke, Ibu. Ruang 10 ya, Ibu. Selanjutnya Ibu Asmaul Husna, ini belum ada konfirmasi kepada kami. Ibu berada di room berapa? Halo, Ibu Asmaul Husna, tolong konfirmasi kepada kami, Ibu berada di room berapa, Bu? Ya, kami melihat Bapak Wahyu Eko juga belum merename username-nya.
Ibu Siti Utari.
Ya, Pak.
Coba lihat Bu, di bawahnya ada nggak menu breakout room?
Bawah mana ya, Pak?
Di samping share screen.
Samping share screen. Oh ya, Pak. Oh iya ya ada, Pak. Langsung dari situ ya, Pak?
Ya, klik join aja ya langsung ya.
Tapi saya di situ ke ruang 04, Pak. Tulisannya. You
ruang...
have been assigned to breakout room R04. Udah selesai yang di situ, Pak.
Oh, sekarang ke 06 ya. Oke.
Ibu Resta. Ibu Resta. Ibu Resta, tolong diganti namanya Bu Resta. Konfirmasi aja di ruang berapa. Konfirmasi di ruang berapa Bu Resta? Bapak Wahyu Eko Yudiak Maja. Bolak mal. Mas Rahmat. Mas Rahmat. Konfirmasi di ruang berapa? Oh, bawahnya di ruang 09 bro. Udah bukan di baik 09. Itu yang atas nama AB92, 63, dan kita ada video. Enggak yang itu. Bu Rimbawati, kita ada video. Bu Rimbawati, konfirmasi ruangannya. Iya, yang dikasih itu dari nomor 7 langsung dari sekitar ini. Itu ada video. Bu Rimbawati. Boleh dikasih sama video semua. Tadi di mana? Sama yang juga usah. Udah ngomong sama Bu Dewi. Kita bilang bahwa ada 08 ya. Udah, 08 ya.
Rabaitul, tolong dikonfirmasi ruangannya. Pak Rabiatul, Ibu itu, Ibu Rabiatul, tolong dikonfirmasi ruangannya di mana.
Ibu Rabiatul Adawiyah.
Pak, iya.
Bu, coba lihat di bawah di samping menu share screen, ada nggak di situ menu breakout room?
Breakout room, ada.
Ibu klik aja itu menu breakout roomnya.
Iya.
Room berapa itu situ, Bu?
04.
Ya, Ibu klik join ya.
Oke, Pak.
Bapak Basuki. Bapak Basuki. Halo, Bapak Basuki. Bapak Ibrahim. Halo, Bapak Ibrahim.
Halo.
Ya, Pak, mohon konfirmasi ada di room berapa untuk
Room 08.
paralelnya? Bapak Ibrahim ada di room
Ya,
08.
saya mau ganti nama dulu ya.
Oke, Pak, biar saya ganti aja langsung.
Oke, terima kasih.
Oke, ini saya masukkan ke room 8. Bapak klik join-nya ya. Atau admin-nya di situ. Oke. Ibu Tessa Iren Sari Simatupang. Halo, Ibu Tessa Iren. Halo, Ibu Tessa Iren. Oke. Bapak Agus Wahyudi. Halo, Bapak Agus Wahyudi. Mohon konfirmasinya Pak, ada di room berapa?
Ada Pak. Siari Pak, dia di sana Pak.
Ibu Novita Sari Harahap. Mohon konfirmasinya Bu, ada di room berapa? 02 Bu ya. Oke Bu, silakan bergabung di roomnya ya. Ibu Bestrika Kurniasari.
Iya.
Ibu ada di room berapa?
Kita nggak tahu kan.
Ibu Bestrika ada di room berapa Ibu?
03.
03 ya.
Ruang 03.
Oke, ini nanti Ibu langsung bergabung di room 03 ya. Halo Ibu Bestrika. Ibu Endah Puji Hastuti.
Yes, I'm India Puji Astuti.
Ya Ibu, mohon konfirmasi ada di room berapa?
Saudara Mono. Halo.
Ya, ada di room berapa Ibu? Halo, Ibu Endah.
Yes. Yes.
Ada di room berapa? Ada di room berapa Ibu?
Room berapa nih ya? Room berapa? 3 ya? 06.
R06.
R06.
Oke, Bu Endah silakan bergabung di room 06. Ibu Endah Puji Hastuti.
Masalah itu di mana? Nggak bisa. Ya tunggu, itu nggak bisa apa.
Halo Ibu Endah.
Gini aja kalau misalnya apa, biar kalau untuk mau share video. Ini sekarang
Bapak Iwan Alvinsa Sihombing.
ini keluar ya suara Bu Nur ini.
Halo, Bapak Iwan Alvinsa Sihombing. Halo, Bapak Iwan Alvinsa Sihombing. Halo, Ibu Tessa Iren.
Iya, Pak.
Ibu di room 3 ya, 03. Halo, Ibu Tessa.
Halo Pak.
Halo, Pak Agus.
Pak,
Ya.
saya nanti kan 4:30 nih. Saya left dulu ya, nggak apa-apa ya?
Maksudnya mau ke 05 gitu?
Enggak. Nanti kan waktu presentasinya kan nanti 16.35.
16.35.
16.50, maaf, 16.50.
Ya nggak boleh lah kayak gitu.
Jamnya 16.50. Saya left dulu nggak apa-apa ya?
Takutnya gini Pak, nanti yang peserta yang di atas sudah selesai gitu, nanti giliran Bapak
Tidak sesuai dengan jadwal gitu ya?
Bisa lebih cepat.
Bisa lebih cepat. Kebetulan saya lagi mau masuk ngajar nih. Saya ngajar dulu kali ya.
Kira-kira ada berapa peserta lagi Pak di antriannya?
Tadi masih sedikit sih, masih 11 kalau nggak salah.
Pak Jerry.
Ya Pak.
Suruh koordinasi dengan moderator di kelasnya, di roomnya.
Oh iya Pak.
Yang tadi masuk dulu dia ke roomnya, lalu komunikasi.
Oh iya.
Makasih Bapak ya.
Ya, Pak Agus silakan ke room 1 dulu ya.
Pak Ibrahim, Pak.
Iya Pak. Caranya gimana Pak?
Pak Agus Wahyudi R01 ya. Oke. Bapak Ibrahim. Halo, Pak Ibrahim.
Ya. Halo.
Pak, menu breakout room-nya ada di samping share screen, Pak. Bapak tadi sudah masuk sebenarnya ya?
Bisa masuk sendiri ya?
Ya, tadi sudah masuk sebenarnya.
Terima kasih ya.
Ya, klik breakout room-nya, klik join.
Iya.
Ibu Murniati Simorangkir. Halo, Ibu Murniati. Oh, Ibu di 02, Bu ya?
02 ya, Bu. Ya, Pak.
Iya. Oke, Bu. Ibu Isnaini. Halo, Ibu Isnaini. Halo, Ibu Isnaini.
Buka mute-nya, Bu Isnaini. Buka mute-nya, Ibu Isnaini.
02 ya, Ibu Isnaini ya.
Ya, oper ke
Dalam kamar.
Oh ya Ibu, di 02 ya. Oke. Silakan bergabung Bu di room-nya.
Klik join-nya Bu, klik.
Halo, Bapak Kasmat Aryansa. Bapak Kasmat Aryansa. Halo, Bapak Kasmat Aryansa. Mohon konfirmasinya, Pak, ada di room berapa untuk paralelnya? Halo, Bapak Kasmat Aryansa. Mic-nya, Pak, dihidupkan dulu.
Selanjutnya kita masuk dalam statistikal alternatif. Dan
Halo.
Halo, Bapak Nil Ananto.
Iya, Pak. Saya di saya di room 5 tadi, tiba-tiba mungkin masalah jaringan.
Di room 5 ya?
Tiba-tiba leave, otomatis.
Oke Pak, coba lihat di bawah di samping share screen, ada nggak di situ menu breakout room-nya Pak? Halo, Pak Nil Ananto. Halo, Bapak Nil Ananto. Halo, Ibu Tita Juwita Ningsih. Halo, Ibu Tita.
Oh iya,
Mohon konfirmasinya Bu, ada di room berapa?
room 02.
Ibu Tita di room 02 ya.
Ya mau ngeganti tapi belum berhasil ini.
Oke, udah Bu, biar saya ganti aja dari sini.
Oke.
Oke Bu, silakan join ya di room 02-nya. Bapak Sahrul Ramadan. Halo, Bapak Sahrul Ramadan. Halo, Bapak Syahrul Ramadan. Halo, Bapak Syahrul. Mohon konfirmasinya Pak, ada di room berapa untuk paralelnya? Halo, Bapak Syahrul Ramadan. Pak Elman. Di room 06 Pak ya? Halo, Bapak Muhammad Yusuf, FMIPA.
Ya, halo.
Bang Yusuf nih, Bang, di room berapa, Bang?
Sama Bu
Paralel.
Nur Juliani.
Ibu Nur ya, di room 4 ya?
Iya, iya mungkin.
Oke, bentar ya. Halo, Ibu Rabiatul Adawi ya. Ibu Rabiatul.
Pak.
Ya, Ibu
Iya Pak, tadi sudah masuk, laptopnya mati.
Oh ya, Ibu silahkan klik breakout room yang ada di samping menu share screen, Bu.
Nggak ada, Pak. Yang ada reaction.
Loh, breakout roomnya nggak ada?
Nggak ada.
Ibu tadi ada di room berapa?
Room 4.
Room 4.
Tadi udah masuk mati laptopnya tiba-tiba. Nggak habisan baterai, lupa ngecas, Pak. Aduh, kapan?
Oke. Ini saya pindah sebentar ke room 1, nanti saya balikkan lagi ke room 04-nya, Bu ya.
Iya, Pak.
Oke, Bu Rabiatul ada muncul menu di situ supaya join di room
Nggak
4.
ada juga, Pak. Belum ada. Cuman ada partisipan, share screen, reaction, more.
Di more-nya Bu, coba Bu klik more-nya apa aja di situ.
More-nya ada chat, ada record on this computer, sama join breakout room. Oh, ya ada, Pak.
Iya, join breakout room-nya ya.
Oke, Pak. Makasih banyak.
Iya, Ibu.
Halo.
Halo, Ibu Indrayani. Halo, Ibu Indrayani.
Iya.
Ibu silakan join di roomnya, Bu.
Iya, iya, iya.
Ada menu breakout roomnya kan di samping menu share screen-nya ya. Gimana Ibu Indrayani, bisa? Oke. Halo Ibu Tazkia. Ibu Tazkia. Mohon konfirmasi Bu, ada di room berapa untuk paralelnya? Halo Ibu Siti Utari. Ibu Siti Utari.
Ya, Pak.
Ibu ada 2 akun ya?
Ada 2 paper, Pak.
Oh, 2 di R06.
Satu lagi di R04, tapi udah selesai juga, Pak.
Oh, udah selesai. Oh ya.
R06 kami juga udah selesai.
Oh iya ya. Oke, Bu.
Oke, berarti saya di sini aja kan, Pak?
2 udah selesai ya, ditunggu aja di sini kalau enggak.
Oke, Pak. Terima kasih.
Maaf, Pak. Ambil revisi, Pak. Sini.
Halo, Bapak Oman Komarudin. Bapak Oman Komarudin.
Iya, Pak. Ya.
Bapak sudah selesai di roomnya?
Oke, Pak. Saya sudah selesai di room.
Sudah selesai di room ya? Oh ya, oke Pak.
Ya, room 06 sudah selesai Pak presentasinya.
Pak. Selamat sore, Pak. Halo.
Halo.
Pak, mohon maaf masukkan lagi, Pak. Tadi keluar sendiri gara-gara jaringan, Pak.
Iya, saya di R5.
Minta tolong, Pak ya. Terima kasih.
Halo. Selamat sore.
Sore, Pak.
Boleh masuk saya di R5?
Sorry, bukan hostnya, Pak.
Oh, iya ya.
Pak Jerry, tolong di transfer itu pesertanya ke ruang 05.
Halo, ya Pak.
Ada satu yang mau masuk ke ruang 05.
Iya, Pak.
Ya. Atas nama siapa, Pak?
Niel. Pak Niel Ana.
Niel Ananto ini tadi ya?
Iya, Pak.
R05. Oke, Pak Niel.
Sama Ibrahim, Pak ya.
Pak Ibrahim di 08 ya?
Iya, Pak. Keluar masuk keluar.
Ibu Retno Susilorini. Halo, Ibu Retno.
Aduh. Ini laban kok masuk laban kok senternya ada yang tampil beda ini. Kok mengelupat oh
Salam alaikum kami dia cuma cium beta. Ayo mama, mama jangan marah beta, lah orang muda punya biasa. Ayo mama, mama jangan marah beta, dia cuma cium beta. Ayo mama, mama jangan marah beta, lah orang muda punya biasa. Ayam hitam telurnya putih, mencari makan di pinggir Mau mere dagali gota ene, pepin disong gesong, lelu ere binha. Putar ke kiri, nona manis putarlah ke kiri, ke kiri, ke kiri, ke kiri dan ke kiri, ke kiri, ke kiri, ke kiri manis. Sekarang kanan nona manis putarlah ke kanan, ke kanan, ke kanan, ke kanan dan ke kanan, ke kanan, ke kanan, ke kanan manis. Mamere dagali gota ene, pepin disong gesong, lelu ele binha. Mamere dagali gota ene, pepin disong gesong, lelu ele binha. La 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 lu si la sol, mi fa sol, la la ti di fa fa, re mi mo re mi, do mi do che mo fa mi re, elele 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 la 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 lu si la sol, mi fa sol, la la ti di fa fa, re mi mo re mi, do mi do che mo fa mi re, elele.
Ladies and gentlemen, especially for the participants, please still stay tuned on our room because there will be an announcement for the best video in a few minutes. Bapak Ibu, kami harapkan untuk masih menunggu. Bapak Ibu peserta, kami harapkan masih tetap menunggu. Untuk beberapa saat lagi kita akan mengadakan closing ceremony dan akan ada pengumuman video terbaik.
Dagali gota ene, pepin disong gesong, lelu ere binha. Mau mere dagali gota ene, pepin disong gesong, lelu ere binha. Putar ke kiri, nona manis putarlah ke kiri, ke kiri, ke kiri, ke kiri dan ke kiri, ke kiri, ke kiri, ke kiri manis. Sekarang kanan nona manis putarlah ke kanan, ke kanan, ke kanan, ke kanan dan ke kanan, ke kanan, ke kanan, ke kanan manis. Putar ke kiri, nona manis putarlah ke kiri, ke kiri, ke kiri, ke kiri dan ke kiri, ke kiri, ke kiri, ke kiri manis. Sekarang kanan nona manis putarlah ke kanan, ke kanan, ke kanan, ke kanan dan ke kanan, ke kanan, ke kanan, ke kanan manis. Biasa sa cinta, satu sapinta, jangan terlalu mengekang rasa, karena kalau sasu bilang satrakan berpindah karena susayang. Jangan kau berulah, satrakan mendua, cukup jaga hati biar tambah cinta, karena kalau sasu bilang satrakan berpindah karena susayang.
kau begitu curiga? Berubah kini kau berbeda. Ikatan kuat atas nama cinta. Setelah suka kau paksa itu masalahnya. Biarkan cinta tumbuh sebisanya. Cinta dan rasa itu pelengkapnya. Jangan hanya datang dan tinggalkanlah rasa tetap cinta walau terus bersuara. Biasa saja cinta coba kau pahami. Sasu bilang sayang jaga satu hati. Raman dua sa berhenti mencari cukup kau dalam mimpi kini dan nanti.
Biasa sa cinta, satu sa pinta. Jangan terlalu mengekang rasa. Karena kalau sasu bilang saat akan berpindah karena susah sayang. Jangan kau berulah saat akan mendua. Cukup jaga hati biar tambah cinta. Karena kalau sasu bilang saat akan berpindah karena susah sayang.
Bilang pada saya kalau rindu pasti ada jangan ragu. Tetapi bukannya begitu. Kau malah marah sampai lupa waktu. Rabana satu pesan. Jujur sayang kau membingungkan. Saya cuma butuh sedikit sandaran. Kau pikir semua itu cuma jalan saat dekati selingkuhan. Dan coba renungkan kembali. Saya perasa tumbuh dan teramati. Kau masih jadi kekasih. Jadi jangan takut saya ke lain hati. Biasa saya cinta satu saya pinta. Jaga hati biar semakin cinta. Percaya rasa jangan dengar cerita. Pegang sapu janji saya tercoba
Biasa
berpindah.
sa cinta, satu sa pinta. Jangan terlalu mengekang rasa. Karena kalau sasu bilang saat akan berpindah karena susah sayang. Jangan kau berulah saat akan mendua. Cukup jaga hati biar tambah cinta. Karena kalau sasu bilang saat akan berpindah karena susah sayang. Titituit damar mati mulia. Siti lunga pasar babi mati semar mendem. Do re mi sol jenang total lagi yo. Mire tahu tempe enak rasane. Waktu terang bulan, udara bersinar terang. Teranglah sekali di kotalah Surabaya. Belum berapa lama saya duduk dengan joget neng kono. Tanjung Perak, tepi laut. Siapa suka boleh ikut. Bawa gitar keroncong tiel, jangan lupa minum anggur. Tanjung Perak, tepi laut. Tanjung Perak, tepi laut. Tanjung Perak, ya jelas tepi laut.
Kacang goreng, kacang barandang, harum pada dia kasih kacang goreng. Kacang goreng si kudo dendang, indah di balik takkan kadang. Iko hari lah mulai petang, kami bercocok si kacang goreng. Mencari makan pagi jembatan, itulah sana kami kureka. Kacang goreng, kacang barandang, harum pada dia kasih kacang goreng. Kacang goreng si kudo dendang, indah di balik takkan kadang. Kacang goreng, kacang barandang, harum pada dia kasih kacang goreng. Kacang goreng si kudo dendang, indah di balik takkan kadang. Iko hari lah mulai petang, kami bercocok si kacang goreng. Mencari makan pagi jembatan, itulah sana kami kureka. Kacang goreng, kacang barandang, harum pada dia kasih kacang goreng. Kacang goreng si kudo dendang, indah di balik takkan kadang. Iko hari lah mulai petang, kami bercocok si kacang goreng. Mencari makan pagi jembatan, itulah sana kami kureka.
capek adikku boleh dari cak sampai balak mari kita goyang sampai jangan terlalu lagi bercuwe kadang-kadang tenaga kita goyang pantai ikut tempo biar ingat sampai sengaja bikin pelan pasti minyak lantai kasih slow kasih slow kasih slow kasih slow tempo kasih slow kasih slow kasih slow atau nanti kacau duh tempo yang santai kasih turun itu gas jangan terlalu kasar nanti bisa terkupas mau alon-alon ikut irama saja ya acara ini kita semua punya ya jadi jangan terlalu hambur itu gaya tahan-tahan simpan-simpan untuk malam berikutnya ay main slow kasih slow biar low kita bikin lantai ini minyak pono yo
Alright. Once again. Alright. Remix. Moving on.
Jamila weta pasareng ngara kau Jamila ate mae saza jauh gang gogora Jamila weta pasareng ngara kau Jamila wabakana Jawa istamang Melayu mesa sare opa kaunya sare
Ladies and gentlemen, the closing ceremony of the second International Conference on Science and Technology Application 2020 will be commenced shortly. Please kindly unmute your microphone if you're not going to have a response, and don't forget to activate your camera as well. Baik, Bapak Ibu sekalian, mohon posisikan mikrofon dan dalam keadaan unmute tentunya. Dan kami juga meminta peserta untuk mengaktifkan kamera pada monitor masing-masing. Acara penutupan akan segera kita mulai. Assalamualaikum warahmatullahi wabarakatuh. And a very good afternoon for everyone. Distinguished guests, ladies and gentlemen. Alhamdulillah, we have come to the final event of the second International Conference on Science and Technology Application 2020, and it is my great pleasure and honor to welcome all of you again this late afternoon. Well, as the first agenda of this closing ceremony, there will be the announcement of the participants who regarded as the best video presenter of this conference. For your information, especially the participants who regarded as the best video presenter, you will be awarded certificate as the best video presenter and internet voucher that will be sent to your mobile phone number by the committee of this conference. Now, I would like to call upon the first Vice Director of Postgraduate School, Universitas Negeri Medan, Profesor Dr. Sahyar MSMM, to announce the participants who regarded as the best video presenter of this conference. Dengan hormat kami mengundang Wakil Direktur 1 Pascasarjana Universitas Negeri Medan, Bapak Profesor Dr. Sahyar MSMM, untuk mengumumkan peserta dengan penampilan video terbaik.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Good afternoon for all. The Honorable Director, Professor Borno Sinaga, Vice Director, Dr. Darwin, Chairman and Secretary Committee, Conference ICOSTA, I am Vice Director, State University of Medan, will announce conclusion and assessment about the best presenter for each room. Yeah. I hope if I call your name, please up your hand, yeah, and you mention your name and your university. Room 01. The best presenter, Oktaviardi Bidyasmawan Abdillah. Open your camera. Where is Oktaviardi? Oktaviardi.
Yes, sir.
Is there?
Yes, I'm here. Oktaviardi.
Mention your name and your university.
My name is Oktaviardi Bidyasman Abdillah from Institut Teknologi Bandung.
Okay, thank you. Committee will give you certificate, hard copy and soft copy, and
Yes.
voucher. Just soft copy, or only soft copy. Soft copy, yeah.
Thank you very much, sir.
Okay, next. Thank you. Yeah. Next, room 02. The best presenter, Muhammad Imam Surya. Open your camera and your speaker. Where is there Muhammad Imam Surya? Open your camera and speaker and your.
Yes, I'm here.
Please mention your name and your university.
My name is Muhammad Imam Surya from Research Center for Plant Conservation and Botanic Garden, Indonesian Institute of Science.
Okay, thank you. Next, room 03. The best presenter, Prislen Haris Banyu Negoro.
Yeah.
Open your camera. Open your speaker. Is there or nothing? Okay. Next, room 04. Putri Rizky Aulia.
Yes, sir.
Open your camera. Okay. Please Your name and your university?
My name is Putri Rizky Aulia. I'm from State University of Medan.
Okay, thank you. Next, room 05. The best presenter, Ziki Yasid Fahmi. So, next, room 0.
Ini diumumin.
Oman Komarudin. Okay.
Yes, sir.
Is there? Okay. Please mention your name and your university.
I am Oman Kamarudin from Universitas Indonesia.
Next, room 07. The best presenter, Hari Tursulistiono Yani Ahsan. Open your camera. Kosong. Next, room 08. The best presenter, Fatimah Arafiati Nur.
Okay, thank you very much. My name is Fatimah Arafiati Nur. I am from Physics Department of
Mention
Institute
your name and
Teknologi
your
Bandung.
university.
Yes.
Once again.
My name is Fatimah Arafiati Nur. I'm from Physics Department of Institute Teknologi Bandung. Thank you.
Okay, thank you. Next, room 09. The best presenter, Retno Susilorini. Is there Retno Susilorini?
Yeah, thank you very much. I'm Retno Susilorini from Sugio Pranoto Catholic University.
Once again?
I'm Retno Susilorini from Sugio Pranoto Catholic University.
Sugio Pranoto University. Okay, thank you. Next, final, room 10. The best presenter, Glisina Dwi Nur Rembulan. There.
Yes, sir. I'm Glisina Dwi Nur Rembulan. I'm from Universitas Bunda Mulia. Thank you, sir.
Once again, once again.
Yes.
Your name and your university.
My name is Glisina Dwi Nur Rembulan. I'm from Universitas Bunda Mulia, Jakarta, Prof. Thank you.
Thank you.
Thank you, Professor Sahyar, and congratulations for all the best participants. And now we would like to invite all of you to pray, and for that, we would like to invite Dr. Wisman Hadi to lead the prayer. Time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Selamat sore, salam sejahtera untuk kita semua. Sebelum acara konferensi internasional ICOSTA kedua ini kita akhiri, marilah kita kembali berserah dan menyerahkan diri kepada Allah SWT sembari memohon ridho dan ampunannya. Bapak Ibu hadirin yang saya hormati, saya akan memimpin doa secara Islami dan mohon Bapak Ibu hadirin berkenan menyesuaikan doa berdasarkan agama, kepercayaan, keyakinan masing-masing. A'udzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Hamdan yuwafi ni'mahu. Ya Rabbana walakal hamdu walaka syukru. Allahumma shalli ala Muhammadin fil awalina wal akhirin. Allahumma ya Allah ya Tuhan kami, dengan mengucapkan puji dan syukur kepadamu atas segala rahmat dan karunia yang telah Engkau curahkan kepada kami. Ya Allah, pada hari ini dengan penuh kerendahan hati, kebahagiaan dan ketulusan jiwa, kami masih hadir secara virtual di forum konferensi internasional ICOSTA 2 ini, sudilah kiranya Engkau memberkahi dan meridhoi acara yang telah kami laksanakan dari tadi pagi. Ya Allah, ya Tuhan kami, seminar ICOSTA kedua yang kami, program Pasca Sarjana Universitas Negeri Medan selenggarakan ini, sangat besar arti dan maknanya bagi kami, terutama dalam mengejawantahkan tanggung jawab ilmiah dan menjalin hubungan silaturahim antar insan cendekia, sekaligus meningkatkan kompetensi kami di bidang yang kami tekuni. Untuk itu ya Allah, tanamkan sifat Rahman dan Rahim-Mu kepada kami, hingga kami dapat berkiprah dalam pembangunan bangsa. Allahumma ya Allah, ya Tuhan kami, dengan telah berakhirnya kegiatan ini, kiranya ya Allah, Engkau dapat melimpahkan ilmu pengetahuan dan kekuatan kepada kami, dan Engkau tumbuhkan rasa persaudaraan dan persatuan yang kokoh di antara kami, hingga terjalin dengan baik dan utuh. Ya Allah Tuhan kami, Engkaulah Sang Maha Pengampun. Ampunilah dosa dan kesalahan kami, dosa pemimpin kami, serta dosa dan kesalahan kedua orang tua kami. Perkenankanlah ya Allah doa dan pinta kami ini. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azabannar. Alhamdulillahi rabbil alamin. Wassalamualaikum warahmatullahi wabarakatuh.
Well, next, ladies and gentlemen, we would like to invite to the stage to deliver a few words of closing the Honorable Director of Postgraduate Program of Universitas Negeri Medan, Profesor Dr. Bornok Sinaga MPD. Please take your time. Dengan hormat kami mengundang Direktur Pasca Sarjana Universitas Negeri Medan, Profesor Dr. Bornok Sinaga MPD, untuk menyampaikan kata penutup.
Baik, terima kasih yang sebesar-besarnya kepada seluruh keynote speaker, partisipan, para peserta seminar dalam dan luar negeri yang sudah berpartisipasi aktif dalam the Second International Conference on Science and Technology Application in Postgraduate Unimed, dan tentu hasil riset keilmuan yang sudah Bapak Ibu bagi mudah-mudahan berguna bagi para mahasiswa, para dosen peneliti, dan dapat menjawab kebutuhan Society 5.0 dan tantangan disruptif Industry Revolution 4.0. Bapak Ibu, sungguh kami sangat mengapresiasi, memberikan penghargaan yang setinggi-tingginya, dan memberi pelayanan mimbar akademik Pasca Sarjana Universitas Negeri Medan buat seluruh masyarakat. Mudah-mudahan apa yang sudah kita kaji hari ini, kita sampaikan berbagai bidang ilmu terkait sains dan teknologi beserta aplikasinya, itu memberikan buah yang berguna bagi masyarakat dan bangsa dimanapun kita berada. Bapak Ibu, melalui pemilihan presenter terbaik, itu gambaran apresiasi kami menghargai Bapak Ibu. Tentu semuanya hasil-hasil riset Bapak Ibu sangat berguna dan bermanfaat. Namun sebagai approach kepada para peserta dan sebagai gambaran apresiasi kebanggaan kami kepada Bapak Ibu sebagai ilmuwan-ilmuwan muda dan ilmuwan yang bermanfaat bagi masyarakat, itulah yang bisa kami berikan. Mudah-mudahan pertemuan seminar ICOSTA yang kedua ini bisa berkelanjutan di masa yang akan datang. Terima kasih semuanya dengan mengucapkan syukur kepada Tuhan Yang Maha Esa. seizin Allah Subhanahu wa taala, seizin kita semua para peserta, maka kami tutup the second International Conference on Science and Technology Application with tema Disruptive Trends of Science and Technology in Industry Revolution 4.0 era. Kami tutup dengan resmi. Nama pimpinan Universitas Negeri Medan, Direktur Pasca Sarjana Pornok Sinaga. Terima kasih Bapak Ibu. Selamat sore.
Selamat sore, Prof. Terima kasih banyak.
Terima kasih.
Selamat sore, Prof. Selamat sore.
Baik, Bapak Ibu sekalian, sedikit informasi dari panitia bahwasanya untuk para pemenang tentunya kami akan mengirimkan sertifikat dan juga voucher internet ya ke nomor HP masing-masing. Dan kami panitia juga akan menghubungi peserta yang mendapatkan grant as the best participants. Thank you. Well, Alhamdulillah, we have now come to the end of ICOSTA 2020. On behalf of all the committee members and the colleague, I would like to express my utmost gratitude to all the distinguished keynote speakers, guests, and all participants for making this event a success. Now, I will leave you a quote by Stuart Brand, an author and innovative thinker who once said, "We can see the past but not influence it. We can influence the future but not see it." So, what we can take from the quote is, let us all be guided by all the things we have learned and heard throughout the conference and be able to see and influence our future. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Tambahan Bapak Ibu, sebelum kita mungkin leave dari room meeting kita, kami himbau kepada Bapak Ibu presenter dan juga author bahwa paper-paper Bapak Ibu sudah selesai direview oleh reviewer. Mohon dicek hasil review ataupun komentar para reviewer melalui akun web sistem ICOSTA Bapak Ibu dengan login terlebih dahulu, kemudian mengecek di menu abstrak. Klik menu abstrak, kemudian nanti di sana akan ada komentar daripada reviewer. Komentar reviewer bisa dilihat di dalam kotak comment review. Kemudian ada juga beberapa reviewer langsung mengupload file yang berisi komentar ataupun revisi-revisi yang diminta oleh pada reviewer. Jadi mohon Bapak Ibu mengecek, kemudian melakukan revisi paper dan mensubmit kembali paling lambat tanggal 10 November tahun 2020. Perlu kami sampaikan bahwa jika lewat tanggal 10, maka kami tidak bisa meneruskan paper Bapak Ibu ke penerbit IOP. Jadi demikian pengumumannya. Mohon Bapak Ibu bisa diperhatikan. Terima kasih. Terima kasih juga atas perhatiannya semuanya untuk telah mengikuti konferensi ICOSTA yang kedua ini. Sampai jumpa Bapak Ibu di ICOSTA tahun depan di tahun 2021. Semoga kita semua sehat selalu dan sukses untuk kita. Terima kasih. Selamat sore semuanya.
Time after time, I've done my sentence. but committed no crime.
Okay, Zin lead.
Bad mistakes, I've made a few. I've had my share of setbacks in my race. I've come through. We are the champions, my friend, and we'll keep on fighting to the end. We are the champions. We are the champions. No time for losers. We are the champions of the world. I've taken my bow, my curtain call. You brought me fame and fortune and everything goes. Well then, I thank you all, but it's been no better road place. No pleasure cruise. I consider it a challenge before the Hollywood race. We are the champions, my friend, and we'll keep on fighting to the end. Oh, we are the champions. We are the champions. No time for losers. We are the champions. We are the champions, my friend, and we'll keep on fighting to the end. Oh, we are the champions. We are the champions. No time for losers. We are the champions.
Nengok Pak. Inilah kondisi dapur kita. Aduh, ya besok mau sidang ini, mau sidang besok.
Ujian besok ya?
Ya, ujian besok. Ya, tolong didampingi ya.
I paid my dues time after time. I've done my sentence, but committed no crime. And bad mistakes, I've made a few. I've had my share of setbacks in my race. I've come through. We are the champions, my friend, and we'll keep on fighting to the end. We are the champions. We are the champions. No time for losers. We are the champions of the world. I've taken my bow, my curtain call. You brought me fame and fortune and everything goes. Well then, I thank you all, but it's been a bad